Well, hello, everybody. We've got a couple people here in the classroom. Thank you so much for everybody who is joining here on Zoom. Welcome to week 2 of Advanced Java Programming here at Portland State University. We continue to live under very extraordinary circumstances, working in this attend anywhere model. For me, I got to campus, saw my reflection in a glass window, and I realized that I'm wearing a purple shirt and khaki pants, and I have forgotten how to dress in public, apparently. So I think you're all wise not to come into campus tonight because I look rather awkward. But enough about me. Let's talk about what we're here to do, which is to learn about some software engineering, to learn about some Java. We've got a lot of cool stuff to talk about and to cover. I'm just going to warn you in advance, this is trying to be another long one. Just like last week, we got a lot of stuff to cover. As a matter of fact, I posted something in the Slack with a big list of stuff that we're going to do tonight. So I'll start off with that, and adjusting my Zoom stuff here. And so I'll walk through what to expect. We're going to start off with Prime Minister's questions, which is your opportunity to ask me anything that is on your mind, any questions that you have coming off the last week. I might also have some questions for you. And then we'll continue our exploration of test-driven development using that student project that we created. We'll be doing a lot of, we'll be writing a lot of code this week, or rather, you'll be seeing me write a lot of code this week. And the reason that we're exploring the student project is because this will give you some of the foundations for your own project one, for your airline project. So we'll be talking about doing some test-driven development. We'll be seeing how to invoke the main method from the student using the command line. That's important. That's how your code will ultimately be run and tested. We'll have a group activity, which is giving you an opportunity to dive into the test cases for the student project and coming up with some of your own. And then we'll implement some of them as what are called integration tests. So we'll talk about the difference between integration tests and unit tests. We'll get a brief introduction to continuous integration using GitHub Actions, and we'll talk about what that means. And then there's more stuff, and so I think that'll be the bulk of me writing code and you watching. And then we'll talk about a bunch of stuff that you need for your projects. So we'll talk about expectations for your own testing that you do for your projects. We'll talk about documentation, what documentation is required. We will see a little bit more code. We'll look at how to use the README resource in the source code. We'll talk about how to submit the projects, and we'll get to see a little bonus because I didn't have everything ready. We'll see how you can pull upstream changes that I've made to my repository that you made that copy of. You'll see how to get those into your own repositories because you'll need some fixes for the submit.sh script. And then finally, we'll look at project 2. So a very full docket tonight. Lots of good stuff that will, I hope, give you everything that you need to then focus on your project 1, and also project 2 will be assigned tonight to get you going in the course. But first off, what can I tell you? What would you like to know? Again, opening up for Prime Minister's questions. As we enter into week 2, what questions do you have? If you have a question, please feel free to raise your hand in either in the classroom or in Zoom, or if you'd prefer, you can post your question in the class chat. Question from Eric, are we going to cover BDD? Not directly. So BDD is behavior-driven development, which is another kind of test-first development where you focus on not a unit of work, but on more end-to-end behaviors. We'll see some aspects of BDD in our integration testing, and the activity that you'll be doing tonight, the group activity, brainstorming tests for the student project, is certainly in the spirit of BDD. I talked a little bit last week about the given, when, then. Well, you'll be doing some when and some thens in your test scenarios. So but we won't be covering in this course our BDD frameworks or Cucumber or anything like that. But what I hope is that I can give you some, that you get experience thinking beyond unit testing to more integration testing. Question from Susan. Are there office hours or times that we are able to meet with you online to look over code/install issues, or just make an appointment? I'll always take appointments. I will try my best to accommodate anybody who asks. Usually I have office hours the hour before class. It turns out that's much easier when I'm either already downtown working, come down here, and you come to Hot Lips Pizza back when Hot Lips Pizza was still in business. So, or when I was completely at home, I could sit there and eat my dinner while before class. Now I'm commuting down here before class, so I don't know if I'll have set office hours this term. If that ends up being a problem, let me know and I'll try to set aside some time. But otherwise, I encourage you and I highly value reaching out during the week. I have to admit that Wednesdays are usually a pretty busy day for me. And if you're having a problem with your project, especially if you're haven't gotten off the ground, last minute emails, I'm sorry, I'm just probably not going to get to them. So it's kind of a forcing function for you to get started early on stuff. But I will try my best to accommodate you. And the more advanced notice that you can give me, the more easily it'll be for me to accommodate you. So Susan, I hope that answers your question. Good. Question from Amila. There we go. Sorry, we were talking earlier today, and my daughter's name is Amelia, so I always want to say that when I see the name. Amila, Project 1 uses abstract base classes contained in my package. How can we see those classes in IntelliJ? So if the project builds with Maven, you ought to be able to see them in IntelliJ. And actually, by C, do you mean see the source code, or do you mean that the code isn't compiling in IntelliJ, meaning that it's highlighted in red? Because the source code, I believe, if you in IntelliJ, the source code, okay. So I'll show you how that works. So we'll go over to my code here, and we'll go to the student class. And if I command click, or if I say, sorry, I don't even know where it is anymore. They moved it. Go to, there we go. Go to declaration or usages. It ought to navigate to the code. So the way I have my Maven repository, or the way I have to apply the code to the Maven, it includes the source code. So I believe that IntelliJ will attempt to download the source code. Amila, can you try real quick to see if you can navigate from the student, so either by doing Command B or Control B to go to that? Thanks. Yeah, let us know how that turns out. Am I getting the? I am getting the pop-ups. Okay. So your question is, if you are using Maven on your development box, do you need to download GitHub? Mm-hmm. Right. Once you create your Git repository, so you do the thing where the bear clone, I'm sorry, I gotta let somebody in. Right. So once you create your GitHub repository, it's yours, and yours for forevermore. That's the only one that you'll use. And so then that's the repository that you should clone to your local machine and work there. Yep. It'll have all of the scripts. Although, as we'll see later tonight, I made some changes to the scripts after you all created your repositories, and so I'll give you instructions in how to get those changes into your repository so that you can get the latest fixes to the script. You can clone directly from IntelliJ, and I've seen that work for students. So it's not the same as the instructions, but it can be done. Yep. Okay. If you follow the instructions are like, hey, install Git on your development box, and I think the Git distribution that I point to has, if you're on Windows, it has Git Bash or Git CMD, which is like a command line environment that has Git all configured and things like that. Easiest way to work with it, and go from there. And so use the command line, the Git command line tools from there. And as always, if anybody has any questions or they're seeing something that is surprising, please post to the Getting Started channel in Slack, and that's where I will look for these kinds of questions. And thank you thank you to everybody who posted during the week. I guess I have a question for you all. How did it go? I got the feeling that most people were able to get things working. I saw a couple of questions in email, a couple of questions on Slack. Did anybody find it confusing? Any feedback do you have for me in terms of the quality of the instructions or steps that might have been missing? Nope. Okay. Well, great. That's good. That's a good sign. I've tried really hard over the last couple of times that I've taught to integrate the feedback that I've gotten to students into the README for the getting started. As a matter of fact, just tonight before class started, I was I added a couple more things to the README. I haven't checked it in yet, and as a matter of fact, I might just do that later tonight. About the fact that when you open up IntelliJ for the first time, you need to configure the JDK. There were a couple of students that I went back and forth with on that. A good point there. And of course, sorry I didn't have that, but I've had an IntelliJ set up for like 15 years now. So there are these things that are all new to me. And plus also I will add a line. Where's my other change? Oops, there it is. Oh yeah, about authenticating with GitHub. All of the examples use the HTTPS, and starting like a year ago, GitHub no longer supports sending your username and password, your GitHub username and password over the internet to authenticate, which is a good thing. So instead, they recommend using SSH keys or using personal authentication tokens. And so I've added some documentation there. So hopefully that will be a benefit to people who will take the class in the future. Okay. Question from Drew. Can we use Vim for Java, or do we need to use IntelliJ? You do not need to use IntelliJ. There will be no quiz on IntelliJ. I will not assess you on your ability to use IntelliJ. If you want to use Vim for Java, that's great. More power to you. I think there are a lot of benefits of using IntelliJ, but listen, if the environment that you're most comfortable with is a VI or Emacs or Pico or whatever, hey, do what's good for you. Using IntelliJ is not a requirement of the course. You will not be assessed. Again, there is no component of your grade that is determined by your use or non-use of IntelliJ. Can we do a question from Susan? Can we do push, pull, etc. to get directly from IntelliJ? Yes. I recommend that. Now, I mean, there are some people, I work with a lot of them, that, oh no, they're real programmers. They use Git on the command line for everything. I'm old, I'm lazy, I want the machines to be doing the heavy lifting for me. And so I like using IntelliJ for Git things. It makes the easy things really easy, and actually I mess things up less when I use IntelliJ. When I try to do things from the command line, I do the wrong Git branch, or I have to like reset my head, wherever the hell that means. I want things to be easy. So I like doing things from IntelliJ, and we'll see examples of that tonight. And of course, if you have any questions, please feel free at any time to stop me and let me know. Okay, anything else? Okay, question from Eric. Not sure if you're going to cover this later, but are we able to set your remote branch as upstream to pull from through IntelliJ? Oh. I think that's a thing you can do. That's a good point. Let's see here. Let's see here. This. I don't know if the manage remotes. Yeah, I bet you totally can. Yeah, so instead of the command line, I was going to go do the example of the command line because that's what's in the readme.txt, but it looks like you can manage remotes here in IntelliJ also. So maybe I'll leave that as an exercise to you all because I want to follow the instructions I'm familiar with. Good question. Okay. Anything else for Prime Minister's questions tonight? Oh, can Maven be run through IntelliJ? The answer is yes. Let me go back to my, minimize that. Oh wait, no, that's what I wanted. Nope, no. It I don't remember if the instructions talk about it or not. But yes, the answer is yes. Maven can be run through IntelliJ. And yes, now can you run them the first time? I'm not sure. There is over here, and the way you do that is over on the very right of IntelliJ. There's a Maven tab, and so you can open up this thing right here. And let's see here, what profiles? Well, we will ignore that for the time being. But here you have each one of your projects. So you have the airline project, you have the cones, you have the student, then you have like the root project, the whole thing. So let's say I want to run the student project, and I want to run these are the goals. So you're probably familiar with a clean and verify. But if you watch the Maven lecture, you learned what compile and test and all this good stuff do. So let's say I want to run, let's say I want to run clean. I can right click and I can say run Maven build. And so now you get some Maven output. It's running clean. So here's all the Maven stuff. Let me get rid of that event log. Get some more real estate here on the screen. Yep, there it is. It ran it all. Now I can run verify. So yes, I mean the answer is yes. You can use Maven through IntelliJ. I think this will work for you. And actually, this means that you don't need to worry about getting things configured from the command line, I think. So let me know how it goes. This isn't how I usually run Maven, but if it works for you, that would be good to know, and always something that we can integrate into the README for future students to know. Okay. Any other Prime Minister's questions? Nope. Okay, well, let's get back to it then. Okay, the first thing that we're going to cover in class tonight is we're going to continue our exploration of that student project. Now, actually, one thing I want to make clear based on some of the interaction I've had with students this week is, you all this week, is that the student project is not required for this course. It is sort of the example that I walk the class through to learn, to explore, test-driven development, to give some code that looks a little bit like your project code, but I hope not so much that it gives away all the answers. So then, I've heard some people make statements like, oh, I'm working on project 0, or, oh, I'm working on my student project. You can do that, but it's not something you're going to get graded on. And so then, be sure to use your time wisely. The project 0 is mainly for demonstration purposes. The thing that is that you'll be assessed on, and the thing that I recommend that you focus on is your project 1. That being said, we're going to spend a goodly amount of time in class today working through the student examples and seeing how to write test-driven development code for it and other things. So let's go back and look at the assignment, though. And I'll post this in the chat so that people can follow along at home, because you will be using this for the group activity. Now, we saw all of this stuff here, but just as a reminder, Project 0 is a simple student class that and a student extends human, which is a course that I used. If you watch the core API lecture, if you watch the Java language lecture, you saw the human class as this whole animal hierarchy, et cetera, to demonstrate object-oriented programming. So a student is a type of human. And students, in addition to having the name that all humans have, they have some additional properties. So students take classes, student has a GPA, and a student has a gender. The GPA is represented as a Java double. The classes that are enrolled in is represented as an array list of strings, and the gender is represented as a string. Okay, that's the way the code starts out. And students have some methods. So the student overrides the says method. I think it overrides it. I can't remember if it inherits it or not. I think it does. And students and all students say this class is too much work. And I believe last time, did we implement a unit test to that effect? No, we didn't. Okay, never mind. Maybe we can do that tonight. And the student class also overrides the toString method to print out a description of the student that we'll see below. Finally, the student class has a main method. Now, a main method is just like the main in C or C++. This is where, when the code is run from the command line, this is where the execution starts. And out of the box, all the main method does is it says, hey, printing missing command line arguments. But what it's supposed to do is create a student based on the command line arguments that are passed in, and prints a description of that student to standard output by invoking its toString method. And so then when you go and, well, maybe I'll go over more of this later, but I just want to show it now, just like we did last time. When we go to, when we build our project here from the command line, I do a clean verify. It'll build all the source code. It'll run the unit tests. It will build the jar file, which is a Java archive, which basically has the compiled bits of the program are all in that jar file. It'll run some integration tests against it. And then it will say, yes, everything was fine, or no, there were problems. It also builds the API documentation. We'll take a look at that next week. Actually, we'll talk a little bit about it tonight. And okay, this build is successful right now. And what this gives us in the target directory is a file called student 2022.0.0, which is the version of this artifact, .jar. And when you run java-jar and give it that jar file, it runs the main method, right? All the main method does right now is it prints out missing command line arguments. So ultimately what we want to do, and we're going to come back to this after we do some test-driven development, is what we want to do is we want to implement the main method so that when it takes arguments like the following, so Dave, so the name of the student is first, followed by the gender, followed by the GPA, and then the remaining arguments are the classes that the student takes. When the main method is invoked with these arguments, it'll print out the statement saying Dave has a GPA of 3.64 and is taking 3 classes, algorithms, operating systems, and Java. He says this class is too much work. So that's what the program is supposed to do. And so what we're going to explore tonight is how to make that program do that using test-driven development. However, there's something that I want to talk about first related to the project, and that's where we're going to start with the TDD. And that's how gender is represented in this project. So I've used this project either as the first project the students work on, or as an example of test-driven development like you do now. This is the very beginning of this course. I started teaching in September of 2000. It was a long time ago. Bill Clinton was still president. It was that long ago. And for many years, when I modeled gender, I had 2 choices, male and female. And then a couple of years ago, on the first day of class, I had introduced the project. And as we were wrapping up class and putting away my stuff, one of my students comes up to me, someone named Trina. And Trina asked me, hey, can I talk with you for a second? I said, yeah, sure. What's going on? And they said to me, it's like, hey, we talked about modeling gender, and I don't identify as female or male. And as a result, I can't use myself as a test for your class. And so then the student doesn't represent me. We had a really nice conversation about it. And for me, it was a very eye-opening experience, primarily about the reality of how people represent and express their gender. But it also, to me as a software developer, had a very important lesson about how we can make the work that we do accessible to the most number of people. So Tree and I had a good discussion, and they provided me with the following statement. I'm not going to read it to you. I appreciate it if you would read it yourselves. But my big takeaways, and I hope that you'll have similar takeaways, is that when our code makes assumptions or restricts what the user can do with it, it limits their ability to use our code. I want my code to be used by as many people as possible. And so then, so Tree and I talked about, okay, what can we do to make this a more real life example? And they recommended that that we include a third gender option of other. And so ever since then, I've modeled the gender in the student as other, male, or female. So I tell you the story as from a human perspective, from a software engineering perspective, but also as an educator perspective. I appreciate the education and what I learned from Trina, and because it's helped me improve the project and the course and the applicability of it in general. So this is where I'd like to start tonight. I'd like to start modeling the gender aspect of this project. So if you look at ultimately what the gender is used for, the gender is used for determining this pronoun right here in the toString. And so then when a student is created with a gender of male, the pronoun is he, female, she, and then other will use the pronoun they. And so let's write some tests, some unit tests for the code to implement this logic. So I have here, I'm going to get my, let's see here, I like to have my code split screen. Now I'm on my laptop, so it's a little small, but I will split and move right. So over here on the right, I have the test for my code under test, which is the student class right here. So we're going to look at the pronoun. And so we'll say this, female, so the first test we'll write is female gender has she pronoun. Okay. So the first thing that I'm going to do is I'm going to create a student. Let's see here. Student equals new student. And student name, well, whatever name doesn't matter. The number of the classes the student takes will be, doesn't matter. Oops, wrong. Okay, let's have an empty array list. And by the way, if you want to know what an array list is, it's covered in, let's see here, the lecture for, maybe it's next week. Anyway, it's the core API lectures. GPA, whatever. And then gender. And so then this will be female. Okay, so that's a student. Actually, we'll just call this female student. Now we'll make an assertion. We'll say assert that female student dot get gender pronoun equal to she. That's what we want, right? So ultimately, so what I'm doing here is I'm writing the code for my student class, and oh, interesting. So this is one way to do it, but actually maybe a different way to do it would say we want the toString for the female student to contain the string, contains string, nope, contains, I think it's contains string she. Let's import it from, Hamcrest matchers. Because ultimately what this output is right here is the output from invoking the toString. So let's run that. Sorry, I'm using keyboard shortcuts. That would have been the same thing as clicking the green run test and selecting one test. It's rebuilding everything, and now it's going to run it. And so what happens? Well, let's see here. We have our test, our student test, female gender has she pronoun. It calls student.toString, and then it throws unsupported operation exception. Not terribly surprising, because that's exactly what we do. So, thinking back to that video that we watched with the guy with the funny hat, now we are in the red state, right? We have a failing test. It compiles, which is good, but it fails. This is exactly what we want, because what we do in test-driven development is that we code our way into passing tests, right? We don't write all the code first and then try to remember all the stuff we need to test. No. We say, hey, let's take each test case, each test scenario, implement it one at a time, get it to work one at a time, make sure that it keeps running after you make every change, and you'll end up with code that passes all your tests and only enough code to pass your tests. And so that when you run out of tests, you can stop coding. It's always nice to know when to stop doing things. Okay, so how do we implement this? Any ideas? By the way, I'm trying to figure out how to involve more people in the conversation because as much as I love hearing the sound of my own voice, I want to make sure that you all don't fall too asleep. So, I'm reluctant to call on people because that is super awkward and stressful. And I also don't know, and actually one of the things I do want to acknowledge is that people who are on Zoom, I have no idea sort of what kind of environment that you're in. And I realize not everybody can or feels comfortable coming off of video or coming off of mute even. So I would encourage anybody though, either here in the classroom or in Zoom, to somehow indicate that you have an idea of how to implement this. We'll start with here in the classroom. Yes. Yes, okay. He had a question about what is this insert that and what is this contain string? That is all covered in the JUnit, in the unit testing, in the unit testing lecture. Those are two methods inherited from what's called the Hamcrest API, which gives you a fluent language for expressing these assertions, which is saying, hey, this is what I'm testing. When I perform some operation, when I establish some scenario, some situation, when I perform some operation like invoking the toString method, then I expect that the output of that contains a string. And that string being she, yes. I'm sorry, and you can't see that because it's all behind here. Yep. I'm sorry? Okay. Good. Okay, so any ideas of how to implement this or where we should go first? Nope. Okay. Be forewarned, sometime during class, I will put you all in breakout rooms. Actually, that sounds like a threat. Sorry. Later in class, we'll have an opportunity to work with each other in breakout rooms. Until then, no one is obligated to come off camera. Okay. Thank you, Amila. Check this.gender in toString. Yes. Okay, so then, yeah, toString. So let's see here. Had trouble importing contained string. Let's see here. Had to add import static. Yep, that sounds good, Patrick. Is it compiling for you now? Is everything green or is it still highlighting things in red? Everything is green. Good. Okay. Nothing wrong with that. That's exactly what you did. So it didn't exist initially, and actually I did the same thing. If you look, it's now, remember this green bar over here in the gutter means that there was a code change since the last time I committed to GitHub. I'm now importing, just like you are, org Hamcrest core. You look like you imported a slightly different one. That one works too. Okay, back to Amila's recommendation of, yes, having gender in toStrings. Okay. Oops. I was looking, not where I was typing. Okay. And so right now, let's just have return this dot gender. Well, actually, I suppose, well, it's not really this dot gender. We want to say, well, let's see here. So we'll have this dot gender. Right. Okay. If it's female, return she. Cool. Good call. Okay. So then, yeah, let's just do that then. So if this dot gender, geez, Dave, learn how to type. If this dot gender dot equals female, then return she. Okay. IntelliJ is telling me a couple of things here because I'm seeing red, and red's not bad. It just means that there's more work to be done. So it's telling me, well, first of all, it's underlying this right here, which is saying missing return statement. Okay. I can, well, I mean, okay, so I'll get back to that. Let me get back to that. Let's go to this one first. This dot gender. Well, it's complaining about that there is cannot resolve symbol gender because I haven't created a gender field yet. So I will, let's see here, I will, for right now, I will right click and say show context actions, which is the same as alt enter in my IDE. So I will do that, and it says, what can I do? Well, I can create the field, I can rename the reference. I want to create the field. That's great. So it creates a field for me. Okay, that's nice. And now let's go back. If this dot gender equals female, return she. Okay. Now it's not quite compiling yet because it's saying there's not a return statement, which is true. What should I return here? What should I do? What are some of my options, do you think? Create a data member pronouns. Oh, that's interesting. Return they. Okay. Yep. That's another option. Sorry? We can only return one string. You can't return he and they. Ah, okay, right. So yeah, hey, why don't you just go ahead and implement the whole thing? Oh, these are great. These are great. Okay, return null, another option. Okay, let's explore all of these in the context of test-driven development. So let's see here. Okay, so null, right? So what are the pros and cons of returning null? Right, if you return null, you have to check for it. So toString, probably you wouldn't expect a toString to return null for a non-null object. So that'd be a little weird. Yep. Yeah, right. That's you probably don't want your toString to return null. It's okay, good. Yeah, Patrick, add another if else, or hey, just we know that there are other genders out there. Why don't you implement those? Aha! This is where like Mr. Miyagi says, "Patience, Daniel-san," right? Where it's like we'll get there, but not now. Because in test-driven development, one of the disciplines that you need to develop is that you don't write any code in the code under test, so no code on the left side, until you have a test for it on the right side. Okay. Susan, return an error message if it's just a test. Aha. I like where you're going with that. Yes, you can return some like, hey, hey, we're not ready for this yet. And as a matter of fact, probably there's a better option that instead of returning an error message, instead we can do what we did before here, which was throw an exception, right? What this used to do is say throw an unsupported operation exception, and now we can say the following: throw new unsupported operation exception. Oops. We'll say gender. This dot gender. This dot gender. Not supported yet. For me, this is my preference. I know it takes a couple extra moments to type all of this, and it's code that you're just going to delete later, right? Because eventually you're going to have all of the genders and everything like that. But for me, again, it's the discipline that TDD requires, which is to work in these really, really small steps. And I know for something super simple like the student class, you're probably screaming at your screen. It's like, no, come on, we know how to do this, right? But then when you get to your projects, and when you get to like your project 4 or your project 5, where things are way more complex, you'll find this discipline really helps you, because it makes sure that you can work in small steps along the way, and you will know very quickly when you've broken something, as opposed to implementing a whole big thing only to find out that, you know what, I made a mistake here. I'll need to go back and rewrite it because now I understand more. It's all part of what I want you to experience and learn with test-driven development. Excellent. Okay, so let's see. We just implemented some code. Let's run our test again to see how we did. So let's see where we're at now. So we'll run this. Rebuilds, and it throws a null pointer exception. Okay. Okay, line 48 here has a null pointer exception. Any idea what's going on? Oh, London. Gender hasn't been initialized. Oh, yeah, right. So let's see here. That is true. Oh, and look, what is IntelliJ telling me? It's all gray here. Private field gender is never assigned. Oh, yeah, that's right. Oopsie. Okay. So let's assign it. Let's assign it here in the constructor. So let's see here. This dot gender equals gender, right? And just to be clear, when I say this dot, it refers to a field of the class. That's this field up here. And when I refer to this gender right here, this is the parameter gender. So this is a pattern that I like. Okay. Oh, and see, IntelliJ is telling me something here because it's highlighted in yellow. Field gender may be final. Now, I would like you to finalize that for me. So make gender final. Okay, look at that. And so I just got rid of that warning. This is something that I recommend that you do along the way. It's a great teaching tool, right? IntelliJ is telling you, hey, there are all these kind of things that are kind of smelly about your code. And so check out those smells because you might learn something and it probably makes your code better too. And so you can look up here in IntelliJ. It tells you, look, I have 2 warnings, 1 typo. Oh, well, what's a typo? This word is normally spelled with a hyphen. Oh, case insensitive. Sure, thanks, IntelliJ. Please fix that for me. Great, thanks. And parameter classes is never used, and parameter GPA is never used. That is true, but I'll use them eventually. So, okay, cool. Now, okay, I like this. Let's go back and rerun my test again. Hey, my test passed. That's pretty rad. Okay, so that was, I went from red. I went to green. What was that last step? So when he turned the hat to the blue side, what was that called? Red, green. Refactor, yes. So refactoring is all about sort of cleaning up the code or looking for duplicate code and making it pretty. We didn't write very much code. And so I can just look here in IntelliJ and it'll tell me all the code that I changed. Nah, this is all good the way it is. Over here in my test. Yep, no big deal there. Okay. So I think this is good. So now I'm going to do, I have passing tests. I have code that's working. My preference is to check it in, right? It's working. Let's put this in GitHub. So I sort of like take a, what's the right word for it? Take a picture of it. I take a snapshot of it. There you go, because I know it's working right now. So I am going to commit these files in GitHub. And I am going to say implemented first test for gender, for including the gender pronoun in the student's toString result. Okay, so sorry, I need to move it around because of the chat. Okay, I will not only commit, I will commit it and push it up to GitHub. Okay. Nice. Let's see here. You know what? Okay, so I realized there. Well, okay, let's go on. What is the next test case that I should write? male, he. Yeah, that sounds good. Okay, so I will, no, let's leave that up there. So actually, I will just select this and then duplicate it with Command D. And we'll say female gender has he pronoun. We will rename this, which you can do refactor, rename, or Shift F6. And we will say this will be male student. Name, blah, 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 blah. Gender is male. Assert that male string contains he. Okay. Now we're going to run our test. You can probably guess what's going to happen, but let's just see what it does. Run. Okay. I get an exception, but look what it said. Gender male is not supported yet. Okay, well, it's not surprising. That's exactly what we told it to do. But isn't this error message nice? It sort of tells me exactly what it is I need to do. So let's go ahead and implement that. And I think, as someone else suggested, all we need to do is have a another if statement. So if this dot gender equals male, then return he. Yeah. Okay. So now let's run it again. Cool. And it passed. Well, that one was super easy. So much so that, hey, let's do the last one since we're here. I don't know if I need to commit that because it was like so easy. Didn't really learn a lot. So let's see here. Other gender as they pronoun. So here, other. You know what? I realized I didn't do the refactor, and now I'm kind of regretting that because I'm seeing some duplicate code. So let's do that. Let's before we write our test. Let's see here. You know, I see an opportunity for refactoring, and yeah, actually I see two opportunities to refactor. Over here in the test, notice how we're basically creating like the same student. It's all different as the gender. So I am going to refactor this whole creation of the student into a method just like we did create student named up here. So remember, like last week, we ended up just creating a student with like a too long name and stuff. Let's just do that, creating a student with a particular gender. So I want to do that is I want to put this value right here, which is the gender, into its own variable. So I'm going to say refactor. I'm going to say introduce variable, or option command V, or yeah, it's option command V. Okay, and I'm going to call this gender. And now I'm going to say I want to take this whole invocation of the constructor, and I want to introduce a method, and I'm going to call it create student with gender. Let's see here, extract parameters to replace duplicates. Oh, no, I don't want to do that. I'm going to say, sometimes IntelliJ tries to be helpful. In this case, I don't think it's very helpful. I want to do what I want. And haha, it was nice enough to say, hey, by the way, I see you're doing something similar here. Do you want to replace that occurrence with a call to create student with gender? Also, I do. Nice. I think this is way easier to read. So we did a refactor, and so after you refactor your code, actually also after you refactor your code, you should run your tests. So I'm going to run not just my newly created tests, I'm going to run all my tests in my class. So I'm going to run all the tests in the class up here. Just make sure I haven't broken anything. Good, everything still passes. I also see an opportunity for some refactoring over here. So we have a bunch of equals. As a matter of fact, I'm surprised that IntelliJ hasn't suggested something. So I'm going to, what I'm going to do is I want to change this to a switch statement, right? Because this looks a lot like a switch statement. And in Java, at least more recent versions of Java, you can switch on string values. So I'm going to, well, actually, wait a second. It popped up this little light bulb here. Replace if with switch. Ooh, that's nice. And I'm gonna make one more thing. I'm going to say default with, and I'm gonna move this throw up here. And I think then everything will still compile. It looks like it. Let's run all my tests again. Nice. Okay. Gosh, and there's one more refactoring that I want to do, and here's what it is. Notice how we have like the string she over here and the string she here. These are like magic strings. Magic strings aren't a good thing because, I mean, let's say I changed it over here. Now I suppose I have a test that would find it, but if I changed it over here and forgot to change it over here, then it would break. So what I can do is I can extract this into one place. I'll make it a constant here in the file. So I will say refactor, extract, introduce constant, static final string she. I am going to call that not she. I'm going to call it female pronoun. Okay, and over here I'm going to call that. And actually, let me look up here, static final this, and so then I'm going to call this student.female pronoun. Okay, I'm going to put a space there because it's static. I'm going to run the test again. Right, and again, by having the text she defined in one place, yay, I can change it in one place and then instead of having to change it in two. I'm going to do the same thing with he. Refactor, extract, introduce, constant. I'm going to call this male pronoun. And I'm going to replace this with student male pronoun. Nice. Okay. That was good refactoring. Right. So this is the whole refactoring step where you're cleaning up your code. You're looking for like duplicate stuff. As a matter of fact, I see some more opportunities. First of all, this variable isn't very useful, so I'm going to do what's called inline it. So I'm basically going to take, instead of declaring a value of this variable is only used in one place. And I don't think this really adds to the readability. Having this variable adds the readability of the method or anything like that. So I am going to inline it into its one use. And so that's refactor. Where's inline? Inline variable. Nice. That puts it right there. Okay. But you know what? I have another magic constant right here, another magic string. So let's do that. Let's create a couple more constants. I'm going to use a keyboard shortcut this time. So I'm going to say introduce constant, which is option command C. So, okay, option command C. I'm going to call that female gender. And I'm going to call this male gender. And I'll go back and change this to female gender. I'll call it student dot female gender. And call this student dot male gender. He seems to be smart enough to recommend that. Let's run all the tests again. Nice, everything still passes. So here, what have I done for like the last 5 minutes? I've just been cleaning up the code, and believe me, this is cleaner code, right? It's it's easier to do there. Okay, gosh, okay, well that felt pretty good. Now I think I'm done with all the tests for now. Okay, so I am going to commit stuff to GitHub. Added support for the male gender and refactored some code. Okay, now let's go to our other gender. Other gender has they pronoun. Okay, so now let's say other pronoun and other gender and they pronoun. So we will create, and sorry, I just hit option enter, which is more actions over here. So a possible dialog says, hey, create field in student. Yes, please. There it is. Okay, and this is other. Interesting, makes it public. I don't need it to be public. Same thing with they pronoun, create constant class. They. That's all right. I don't want it to be that. Okay, well, let's run it. I'm using keyboard shortcuts now because it's a little faster. And yep, gender other not supported yet. Well, this should be pretty easy. Duplicate. So see how it sort of becomes wash, rinse, repeat after a while, and that's fine because let's see here, other pronoun. Oops, sorry, they pronoun. Because it's easy and you don't need to think very hard. And who doesn't want that? Nice. Okay. And so let's run everything else. Make sure our code still runs. Cool. And it does. Okay. So let's see here. What is next? Is there anything else about gender? Let's just check this in. Implemented other gender. Let's see here. Gender. So I'm going to see, what did I write about gender? Gender, students, gender, male, female, or other, case insensitive. Oh, wait, case insensitive. Oops. Oh. Case insensitive, which means other gender, case insensitive, has they pronoun. So I guess it's really supposed to take like other. Oh. Yeah, it ain't gonna work. Okay, what do I do? Drop the class, change my major, go study functional programming where you never have a string. What do you do? Yeah, fix it and make it work, I guess. All right, so let's see here. To uppercase. Oh yeah, there you go. Let's see here. Yeah, how can we use to uppercase? Oh, no. Huh, yeah. You know what? Now I'm wondering whether or not having these constants. Yeah, do we need to go back to ifs? That's a good question. Yeah, I kind of think we do. Yeah, I think we do. Okay. Yeah. Okay. Sounds good. Let's see here. I bet IntelliJ can help me with that. Help me, IntelliJ. Give me the little light bulb. Replace switch with ifs. Oh, thank you so much. Oh, yay. Okay, good. Although it'd be nice if they were readable ifs. Okay. And now instead of saying equals, I want to say equals ignore case. Oh, good. Okay, do that. Equals ignore case. Equals ignore case. Okay, good. How about that? Yeah, that passed. Let's run the rest of the tests. Okay, good. Everything still passes. Susan, I see your question. Let me just check this in and then let's get to that. So let's see here. Ignore case when comparing gender strings. Okay, Susan asked a question. When you push run, where do we look on the IntelliJ page to see what files are being run? Oh, that is a good question. So, okay, I'll just run the test again. Okay, and that brings up this run tab right here in IntelliJ. And so over here on the left, it tells you what the test results are. So it's telling you, hey, from the student test class, I am running the following methods or the following test cases, right? So student name Pat is Pat, and so these are all of your test methods. So that's how you find out. Now, what I've learned is that if you click over here and then you right click and you can say jump to source or use F4, that'll take you right to the source code for the test that's being run. Did that answer your question, Susan? Cool. Yes, good deal. Okay. Well, let's see here. You know, in the past, yeah, I think this is good enough for now. Okay. Yeah, so I think I'm ready to move on. I think I have exhausted all the functionality related to gender, right? So looking at the assignment, looking at the requirements, these are the three valid values of gender. You know what? I realized that there's something else that we should have included. What if we have a unrecognized gender? Okay. So let's see here. Test. This kind of brings us back to a question that we thought of before. Unrecognized, recognized gender does what? What happens when you create a student with an unrecognized gender? What should happen? Throw an exception, error message. Yeah. Okay, I like that. Throws. What kind of exception should it be? We could use something like unsupported operation or illegal argument. But you know what? A pattern that I've seen that I actually kind of like is that we use like a custom exception class. So we'll say it throws an unrecognized gender exception because we can create our own exception classes. Let's do that. So let's see here. When we create student named unsupported, we expect that this code will throw an exception. And so I have an example of how to do that up here using a try catch. And actually, this is not the preferred way to do this anymore. So you can instead use a method called assert throws. Now, assert throws takes, the kind of exception expected to be thrown. So here it's going to be an illegal argument exception. And you say legal argument history about class. We will see this in the reflection lecture. Until then, just believe me that you can represent a class for a particular class by saying the name of the class.class. And then it takes something called an executable. Now, an executable is really any method. And so another syntax that you'll learn about later on is something called a lambda syntax, meaning that you can say this and then this. So you don't need any of this code anymore. And what this basically is saying is that, listen, when I try to invoke this code right here, create student with this too long name, I expect that an illegal argument exception is thrown. If it's not thrown, then the test fails. So let's run this one test and see what happens. It should still pass. It does. Great. Which means that down here, when I'm going to assert throws, and this is going to be an unrecognized gender exception, unrecognized gender exception dot class. It's saying unrecognized gender exception doesn't exist. That is true. I'm going to put it in the student class. A little advanced for week 2 with this thing called a nested class or an inner class. I can use Alt-Enter to say create that class. It creates a class within a class. One problem detected. Why is it complaining about that? Oh, it's probably complaining about that because, again, add import. Okay, well that's not what I wanted. It probably is complaining about it because it doesn't extend an exception. So I'm going to extend something called a runtime exception. Anybody remember off the top of your heads what a runtime exception is and how it differs from a plain old exception? They both happen at runtime, but sorry, what? No, yeah, I think we're getting close there. What were you saying? No, not so much a segfault type thing. As a matter of fact, segfault in a JVM is super, super bad, right? I mean, that means that something is crashed inside the VM, not just in your code. No, a runtime exception. Josh has it. Runtime exceptions don't need to be declared and caught. Correct. So there are some exceptions, and you'll learn about it when you start doing I/O. There's like I/O exception where you have to catch it or you have to rethrow it like all over the place. And that's okay because I/O exceptions and plain old exceptions are not terribly unexpected. Where runtime exceptions are things like array index out of bounds exceptions and divide by zero exceptions. These are kind of unexpected and they're easy to test for. So I'm going to choose this to be a runtime exception. What is it telling me? It is telling me that it may be static. Well, that's nice. I can make it static. Sure, why not? And okay, good. Now the code all compiles, so now let's run it. It says expected an unrecognized gender exception, but nothing was thrown. Well, that's exactly what we had to have happen. So now our test is red. Let's make it green. How are we going to make it green? Well, let's see here. Let's add something to the constructor. And instead of just blindly assigning it, we should check to make sure it's valid. And then I have to like re-implement all this logic down here, and I don't really want to do that. So here's what I'm going to do. Instead, I am going to put all of this code into its own method and then just call this method for my constructor. And I'm going to do the following. Okay, so I'm going to select this code and I'm going to say refactor, and I'm going to say extract introduce a method. So here I'm doing some refactoring in order, and sort of like prefactoring. I don't know. I'm doing it because because it'll make it easier to write the code. I'm going to call it get gender pronoun. Nice. And then I'm going to then I'm oh well, you know what? No. Okay, now I'm going to change something here because instead of saying this dot gender, I am I really want this to be the gender pronoun now. I don't think I really need to. Yeah, I'm going to change this to be the gender pronoun. So let's see here. But first, I want this to read get gender pronoun. Sign up. Okay. I'm going to have this be get gender pronoun, and I want to pass in gender right here. And so then I'm going to say add string as first parameter. It's going to be gender. Yes, please, just do your thing. And this is going to be gender pronoun instead. Thank you, IntelliJ. And now down in here, I don't want this to be called a get gender pronoun anymore. I just want to return this gender pronoun. And then here, I don't want, there isn't a field anymore. I'm just going to return all this. And I realize I'd be pretty fast. If anybody missed it, then either ask a question. Oh, sorry, and it looks like there are a couple questions that came in that I missed. Yeah, what does the this thing, the parens arrow mean in the assert throws? Josh is right, it's a lambda expression. There is a lecture on this, it's the Java 8 functional programming lecture that you'll see in a couple of weeks. Feel free to watch it now, but you might find it a little advanced. There are also some cones on this. But it's just a shortcut for basically saying, hey, invoke this code in a special way at a special time. Okay, everything looks like it's all green over here. I don't have any complaints. Let's run the test and see what happens. Assertion failed, error, expected an unrecognized gender exception, but was an unsupported operation exception. Ah, yes, I forgot to change this code right here to an unrecognized gender exception. And what is it complaining about? It's complaining about accepted 0 arguments, but was 1. Okay, so I will create that constructor, and this will be the message. And I will send this to the inherited constructor from exception, because I know that's where the message goes. And now I'll run that there. I realized that there was one more test, one more thing I wanted to validate. So assert throws returns the exception that was thrown. So let's see here. Unrecognized gender expression EX equals assert throws. This is kind of, I am going to do a static import of this. So it's a little easier to read. I'm going to put that in the line so it's a little easier to read. This is going to be my invalid gender containing block. I'm going to say invalid, or sorry, unrecognized gender. And I'm going to assert that the message associated with my exception contains string unrecognized gender. So what I can do then is I can not only assert that an exception was thrown, I can capture the exception object, and I can interrogate, and I can say, hey, if an exception was thrown, I want to make sure that exception contains the gender string. I'm pretty sure it will. Oops. Oh, that's right. Wait, gender doesn't matter. Oh. Oopsie. What? So it's interesting. It said it should have unsupported, but gender doesn't matter, not supported yet. Oh, because I used the wrong thing. Create student with gender unrecognized string. Haha. Well, that was a good thing that I it's a good thing that I added this exception then, because it turned out there was a bug in my test. My test wasn't right, and I thought it was doing just the right thing, but it turns out I wasn't doing the right thing. I'm glad I added that extra test then, extra assertion. Cool. Now, but I think this tells me something. So I got that test case to pass. So now if I run all of my tests, oops, I broke some stuff. Student name Pat is named Pat. And now when I went and created my student, I called get gender pronoun, and through the exception, let's take a look at the test. Create student named. Oh, well, it doesn't matter. Let's just use other than. Run all my tests again. This is a great example, right? I have added some more validation, and it broke one of my older tests, right? This is like the test that we wrote last week. Now that I've changed, I've added some new stuff to my code, I broke one of my tests. This is a good thing, right? This is what unit testing gives you. Unit testing gives you an entire validation suite that validates all of the assumptions that you've made up until this point. And I find this to be very powerful. For me, this helps me go fast. This detects errors that I make way faster than if I had like written all the code and I've had to go back in time or go back and try to figure out all the mistakes that I've made. You know, I think a valid criticism of test-driven development is that it seems so slow. I mean, come on, I know exactly what I need to write over on the left. That is true because you're smart people, and it's a pretty easy problem. Let's face it, right? But I've found through years of experience that test-driven development saves so much time on the back end, right? It saves debugging time instead of, and so then all of the time that I would have spent debugging, I spent a lot less of that writing tests. And especially if you have a code base that's going to live for a long, long time, which in the real world you do, it saves you just so much time over the lifetime of a project. Anyway, super cool. Okay, so now all my tests are passing. What did I just do here? Oh yeah, right. I handled an unrecognized gender. Actually, you know, I could find that pretty easily by saying, hey, what are the changes that I made? And so I can say show diff, and that brings me this side-by-side comparison. Which actually I find this kind of hard to read. Can I move this out of the? Oh, this used to be in. So you can do a side-by-side comparison of here's all the stuff that's changed. That's kind of nice. You can see what it is, but now I remember what it is. And so I will just say commit files, and I will say when the student's gender is invalid, throw an exception, which is actually kind of like the test case that I wrote. She did the test case that I wrote. Nice. Okay. So, granted, that took like an hour to do, but I was doing a lot of talking, and I was, showing off some things about refactoring and all of that. And now it's time for a break. Well, sorry, any questions first? Any questions before we take a break? I just gave away the ending. I think everybody wants a break. Okay, let's take a 12-minute break until the top of the hour, and then we'll come back and do a group activity. So please be sure to come back because we'll be breaking into breakout rooms. Zoom recording. Okay, everybody, welcome back from break. So let's see here. Tonight, we've done Prime Minister's questions. We looked at doing some test-driven development focused on the gender pronoun. Next, I want to talk about. I want to talk about doing a different kind of testing, and that is looking more holistically, not just at a unit of the code, but at the entire program itself. So remember, the main method, when the main method is invoked, the command line is parsed. So each argument of the that is passed to the command line is examined, and from that, a student object is created, and a description of that student is printed to standard out by invoking its toString method. Okay, so what does that look like? Again, going back to the PDF. When we run this command line, java-jar, so this takes an executable jar file and runs it with the command line, or sorry, with the arguments Dave, mail, 3.64, algorithms, operating system, Java. You get this thing right here. Dave has a GPA of 3.64 and is taking 3 classes: algorithms, operating systems, and Java. He says this class is too much work. So that's ultimately what we want to do, is to provide that kind of thing. But as you can imagine, as a matter of fact, as I hope you can imagine, there's like a lot of different permutations and combinations of parameters that you can send, and the output is going to be different based on the parameters. So here's what I'm going to do. Now we're going to do an in-class activity. This will give you an opportunity to work with some other people, and I want you to brainstorm test scenarios for the project. And I'm going to use this, and so let me share this document with everybody. And what I'd like you to do is, let's see here, anyone with the link can edit it. So let's copy the link. So here is the link to the test cases. Well, actually, so please contribute your test scenarios on this Google Doc. So, given when then, someone asked about behavior-driven development. The whole idea is that when you have a test case, or when you have a scenario that you want to validate, there are three parts to the scenario that make sense to specify. And they're called given, when, and then. So given is all about the conditions that are that exist before the conditions that exist. So you do some setup, basically create something. Now here our given is really not in code. It's the fact that the code has been built and an executable jar file exists and can be run. Then there are two other parts. There's the when and the then. The when is the operation that you're going to validate. So that's the thing that you perform. So here it's like, hey, when an executable jar file is run with the following command arguments, that's the sort of the test that you're running. And there's the then, which is like what you expect to happen. And so then let me fill one in now before we get started from the, I'll do the easy one. So when the command line is, I'll just copy this and paste it in here. So when these arguments are provided, then, well, we'll just say, come on, copy and paste. Here we go. Then this text is written to standard output. So what I'd like you to do now is, well, I'm going to divide you up into breakout rooms, and let's see here, how many students? Well, sorry, I'm going to divide you up into breakout rooms, and what I'd like you to do is spend 15 minutes. 15 minutes brainstorming amongst yourselves various scenarios. So basically various when-then scenarios. So, hey, listen, when I put this stuff into the program, here's what I expect to happen. And this is to be an exercise for us to crowdsource all of the particular behaviors that we want to implement in our program. And this will give you all an opportunity in your breakout rooms to talk about, hey, what the expectations are. And then we'll come back together as a group and we'll review them. And we'll figure out if there are duplicate ones. We'll figure out if there are conflicting ones. Maybe one group thought it should behave with the same input. It should have output A, maybe output B, and figure out which one is right. And then after a brief discussion about that, we will then implement some of these in what are called integration tests. So, but first I'm going to ask you to brainstorm these when-then situations, and then we'll implement some of them. Before I send you all to your rooms, any questions on this? On this little exercise right here. Nope. Okay. Let's go into breakout rooms. Let's see here. We have how many? 20 people remote. Let's do 5 breakout rooms. And I'm going to assign you automatically. Let's see what happens. And if it's a horrible experience, let me know. Okay. There we go. I'm going to open them up, and please go to your breakout rooms. Share my screen. Okay. So nice going, everybody. We came up with a nice long list of lots of test scenarios. Let's see here. Cool. So before we dive into these, I'd like to give you all an opportunity to share your thoughts on this exercise, what it was like writing test cases. So feel free to put some words in chat about what you observed. Also, if you would like to, if it's easier for you to speak your observations, feel free to raise your hand and I'll ask you to come off mute. So what did you think of this exercise? Going through these given, when, then scenarios, partnering with other people to explore the potential behaviors of the student main method. Lots of possibilities. Having time to think is helpful. Good. Yeah, there are a lot of possibilities. I mean, it seems like a pretty simple thing, but then when you start exploring it, wow, there's lots of things could go wrong. Or hey, what happens in this scenario? Anything else? Other ideas that people have? Thank you, Amila, and Jacob for and Susan got one too. It's good to see ideas a few people have all together. Yeah, it's good to brainstorm ideas together. Okay. Well, now, so as I started seeing people's scenarios, I realized that there were some expectations I should have set beforehand. Oh, Josh got one. Understanding the intent and functionality of the program is important for defining test cases. Yes, exactly, and that's why we do it. So I mean, it's a great observation, Josh, because it's through exploring these test cases that we discover the intended functionality. Both the ones that are maybe there between the lines in the description of the assignment, and then also ones that you have to decide how is it going to behave. And and this is a very important skill to have as a software developer, because it's not like you're handed an assignment. It's like, great, if you do all this, you get an A. It's like, here's a problem to solve. Figure out how to solve it. And so there's lots of complexity. That's why we get paid so much. Is that where we have to deal with these very open-ended and malleable problems that we learn about and we discover along the way. And the trick is, and the best software engineers can very rapidly sense the situation, gather data, figure out, look at feedback, read signals, analyze all that, and figure out what to do. Right? It's this whole pattern of taking in information, processing information, acting on that information, gathering more information, just going in that loop. Anyway, cool. Well, so then let's look at. Oh, and so then it was, as I was reading some of these, some of them were like, oh yeah, throw an exception or throw an error, which might happen internally. But then I realized that I should have said, well, instead of just the following is expected to happen, I should really say the user should expect to see the following. So in what we're dealing with right now, we're dealing on the command line. This is what the user, and by the user, it's the grader. What the grader is going to do is the grader is going to run your command line program, and with various input arguments, and then the grading script is going to record the output, and then the grader is going to evaluate. Well, is that output the output that I would expect given those inputs? And so then I pasted in this error handling section from Project 1, which talks about the fact that the program should exit gracefully, so it shouldn't crash. It shouldn't just have no error or have a unfriendly error message like invalid input, right? And that the user shouldn't see stack traces. And so then, hey, if something's missing from the command line or there are extra arguments, or in Project 1, it was all about the format of the date time, but you can imagine, I think I saw some examples of invalid GPAs and things like that. So, and the reason that we're going through this is that you'll need to go through a similar exercise for your projects as you write them to make sure that you have provided a good user experience for the user of the command line. Okay, so now let's walk through some of these. And here, I'm just going to do that. Okay, so that was one that I put in. Let's see here. So let's go through. So when let's see here. When Dave Mail 3.64 algorithms and operating systems is entered, throw error not enough arguments. Well, this is interesting. Why are there not enough arguments here? And so it sort of begs the question, well, I mean, according to this student is taking 2 classes. Is it okay to only take 2 classes? The assignment didn't say. Let's see here. Josh says, yes, it's okay for the student to take 2 classes. All right. But it looks like the intent here was that we want to have not enough arguments. So let's see here. What input would have not enough arguments? Let's see here. If we just said those 3, is that not enough arguments? Is a student required to take a course? Just say no. Okay, and then Susan says just Dave Mail. That's not enough arguments because the student doesn't have a GPA. Okay, let's say that much. And so then let's I suppose we could name this. Well, this is like, no, this is probably fine. And then instead of throw error, well, when I see throw error, I hear, throw an exception in the Java code, which might happen, but that's not what we want the user to see. Instead, we probably want, the following is written to standard error. Not enough arguments. Okay. So I'm polishing up the test cases here because we're going to be implementing them pretty soon. So that's a good one. Okay. Extra arguments. So Dave Mail 4.00 algorithms operating systems extra argument. And so then the program creates an object excluding the extra argument. Well, that's interesting. So if the program is parsing this input, how does it know that this extra argument is an extra argument and not a class named extra argument? In fact, can you even have extra arguments for this program? Maybe is there an upper limit to the number of classes a student can take? I don't know. I suppose we could do it that way. Let's see here. You have to know how many classes the user intends to enter. Yeah, that's a good point. So Susan says no, there shouldn't be an upper limit. No limit. Yeah, right. Josh says, hey, the program spec didn't say anything about it. And it says 0 or more classes in the comment. So maybe this isn't a valid test case, which is fine, right? You're just brainstorming. It's okay to come up with things that ultimately get discarded. It's much, it's much better to like explore the potential scenario than it is to ignore it. So this one, I don't know if it's valid. So let's delete that one. I don't think we can call it one valid, or maybe we should. I don't know. Should we like color code it? Nah, sorry, So that one I don't think is delete row appropriate. Okay. Okay, there we go. Dave, other 4.01 algorithms. Aha, 4.01 is not a valid GPA. Yep, that is true. Same thing with this one, a negative GPA value. And I think here, right, instead of throwing an error, it would be the following output. Well, the following is written to standard errors. Standard error. Invalid. I kind of like this error message right here. -346. Okay. This is a good one. The GPA is not that. Well, here again. Let's do that and instead say foo. is not a GPA. Nope, 4 classes. That's good. That's good. Oh, this was interesting. So not a valid course for first course argument. So how do we know that that's not a valid course? Because it's not a word? Yeah, see, I don't know how do we know? Because maybe it checks some PSU course names. Yeah, maybe. Checking its list of valid courses. Yeah. Well, I'm not going to implement that one tonight. I can tell you that much. So okay, yeah, that's this is good, right? Again, we're exploring the boundaries, and like with any problem set, you need to draw the boundaries. You need to say, hey, there are some things that are going to be within the scope and some things that aren't, and that's when you sort of then you got to try your best initially, and then see what your users think. It might be that you find that, oh my gosh, your users are always entering these like non-existent course names, and you got to implement something. Good. So anyway, there are a lot of these here. I'm going to skim through the rest of them. GPA, missing name. Oh, this is an interesting one. Missing name. That's probably not the actual error that, and we can get to that one later. That one looks okay. Oh, sorry, is this over 2 lines? Yeah, okay. Good, 3 classes. That one seems valid. Okay, high up, empty. Okay, an empty string. Missing arguments. Either that or gets interpreted as an invalid GPA because it's expecting the third argument to be a GPA. Too many arguments. I see what we're getting at here, right? Because okay, great, we have a when a human reads this, they say, oh, that is a 2-parameter name. When the computer reads it, it's probably not going to know. Instead, it would probably expect the second argument to be second argument to be the gender. It would say Grohl is an invalid gender or an unrecognized gender. No, this is good. And the name is too long. Okay, awesome. Well, hey, while we were doing all this, did anybody think of any other test cases that they wanted to add? Anything that we've missed that we want to be sure to call out here? No. Okay. Oh, that's a good point. So let's see here. Right. Is it valid to have integers in your names? Well, that's a good point. Boy, what makes a valid name these days? If I was a child of someone famous, I might have emojis in my name. I've got no idea. Exactly. Yeah. There you go. Right. So, but these are all great questions to ask about what assumptions you make about the software that you write. What's valid input? What is a valid way to display things? And even though you won't always get it right on the first time, it really helps be deliberate about these decisions, to talk about it with other people, to get other ideas. And you know what? It's just like the assumption that I made about modeling gender in the student class, right? So for many years, I thought, oh yeah, right, binary, male and female, and that was sufficient, and that was the right thing to do. But then, I learned more, and I learned that there are other students that can't be represented with my code, and therefore my code is defective because it doesn't work for a lot of people. So this is the exercise that we're doing here, and this is an exercise I encourage you to do as part of developing your own projects. Okay, now let's implement some of these. So ultimately, when we have what we want to do is when we run our program with these with these inputs, we want to print out this description of the Dave student, although right now it just prints out missing command line arguments, which is just plain wrong. And I want to develop this functionality for my main method using test-driven development. Now, when I invoke the main method, reads things from the command line, and it interacts with standard error and standard out. And I guess something else that I wanted to do is that when the input is invalid, I wanted to issue an exit code. So have you learned about the exit function in C and C++? The whole idea is that it sets the process code, the process status code that is returned to the shell, to the invoking environment when the program exits. Oh, good. Looks like you have. And so I want to do that too. So, however, the main method, therefore, the main method will do things like call system.out.println, and it will invoke system.exit in Java. And if you do that in a unit test, if you just have a unit test that calls system.exit, the entire JVM is going to exit and your tests are going to stop running. That's not what you want. So plain old JUnit won't do it for you. And when plain old JUnit won't do it for you, it probably is an indication that you have something more complex than a unit test. And so there is a second category of automated testing that we talk about in this course, and that's called integration testing. So the whole idea that integration testing is it involves more components. Unit testing is all about methods in a class, right? Very simple stuff. Our unit test just used the toString method, created a student object and invoked the toString method. That's really all it did with it. When you're doing something more complex, like invoking a main method that interacts with standard output and standard error, when you are in project, actually in project 2, you'll be writing to files, right? That's another, it's more advanced than so you want to write something to a file and then read it back in again. That's more complex. For those kinds of things, you want to use what are called integration tests, which require more setup normally and are more capable and exercise more capabilities than plain old unit tests. So for the command line projects, so projects 1, 2, 3, 4, 1, 2, 3, and 4, you'll be writing mostly unit tests and some integration tests that exercise the command line functionality, the main method. In project 5 in the REST API, we'll see really complex integration tests where you do things like start up the web server and invoke the URLs and stuff like that. So it'll really hit home then. In the meantime, I want to present this distinction between unit tests that work just on an individual class and integration tests that span multiple classes to, or in this case, the main method. In your later assignments, in your assignments, you might have tests for your airline and your flight and your project 1 class. It's up to you. But there are two flavors. There's integration and there's unit. Let's see this in action. So if you go over to your project and look in the student, in the source directory, there are 3 subdirectories. There's main, which is where your student lives. There's test, which is where your student unit test lives. And there's something called IT, which stands for integration. And this contains a class called student IT. So if we open this up, it's got 2 methods out of the box. Now, these integration tests that I have, they all extend from a class that I wrote called invoke main test case. And this gives you some helper methods for, invoking the main method of a class. And otherwise, though, it uses plain old JUnit. So it uses JUnit, uses Hamcrest, things you're all familiar with, or becoming more familiar with. So when I want to run the main method of my class under test, so my student class over here, I call invoke main and I give it student.class, which says, hey, invoke the main method of my student class. This returns an object which is of this type main method result, and this main method result has various things. So you can get like the exit code from that was invoked by system.exit over here. And so what this unit test, this integration test does, it says, hey, listen, when I invoke the main method with 0 arguments, then I expect that the exit code of the exit code from calling that main method is equal to 1. And sure enough, when I run it, that's what I'll see. Oops. This is a great example and exactly what I meant to say. So sometimes you get this funny error. It says could not load class with name this thing. To solve that, you go back, and I'll explain this to you again in a little bit. and you run just a Maven clean, and that'll take care of it for you. Sometimes when you run things from the command line, or run things from Maven, IntelliJ gets a little bit out of sync. So you just got to clean up that environment there, and now IntelliJ will rebuild everything and run it, and now it's happy. The second integration test validates that when I invoke main with 0 command line arguments, the text written to standard error contains a string missing command line arguments, because over here we call system.error.println missing command line arguments. Sure enough, when you do that, yep, that's what is written to standard error. So I wrote this API for invoking main that lets you, invoke your main method, exercise, what's written to standard error, what exit codes are returned, all of that good stuff. So now what I'm going to do is I'm going to start implementing some test cases that will exercise the scenarios that we called out over here. So just for the sake of getting started, let's start with the end in mind. So Dave's student is written to standard output. So how do I implement this? Well, I say invoke main, and I say student.getClass, and the arguments here are, let's see here. If I just paste here, does that give me something good? It does not. Best to do that. Let's do it this way. Okay. So the first argument is Dave. Second argument is the string mail. By the way, these are all strings, right? Because it's what's sent to the main method. The 3 classes are that, operating systems, and Java. So let's see here. So now, oops, I'm missing a comma. This is what I invoke it with. And now if I assign this to my result, you know what, I'm going to use, result. Then I want to say assert that. Well, first of all, I want to say result.get exit code is equal to, get exit code is equal to 0, because this is a happy test case, right? There's nothing wrong here. And secondly, I want to assert that result.get text written to standard output is equal to this whole thing right here. Actually, I think it has a period at the end. Like that. Yep. That's the whole thing there. So that's ultimately what we're trying to do, right? This is like the the big old test case that I'll validate that lots of things are working. As a matter of fact, I'm going to switch the order of those two. So now if I run it, it failed, saying that, hey, I expected this whole thing to be written out to standard error, but was nothing. But nothing was written, which is true. So that's all we have implemented. So good. This gives us like a sort of a measuring stick to figure out how close we are to implementing all of this stuff. So let's start looking at our other test cases. Let's see here. Dave mail, not enough arguments. Well, so let's see here. Let's implement that. Void. Let's see here. Actually, there's a simpler test case, which is just providing the name. So only name. Let's see. Only providing name. Only providing name. Issues. Not enough arguments, error. So now, if I say invoke main for the student class with only one argument. By the way, the var keyword here can be will make it so you don't need to put that whole big old type there. It's a little easier to read. So we'll assert that result.get text into the standard error returns. I want to say not enough arguments. What I really want to say is missing gender. For me, I think it's a much better much better error message. Oops. Equal to missing gender. And I also want to assert that result.get exit code equal to 1. Cool. Let's see here. Expected missing gender, but was missing command line argument. That's what I expect. By the way, before I go back and make this thing pass, this Dave student is written to standard output. This is not ready for prime time yet. So I don't want it to run yet. So I'm going to mark it as @disabled. This basically tells the JUnit test runner, hey, listen, yes, it's a test method, but don't run it because it's not ready yet. The reason I'm just commenting it out is that if I change anything about, like if this calls a method and I rename that method or whatever, I want that to be actual code that's refactored or that is compiled at least. I just don't want it to be run as a test. Okay, so back to this one, which is failing. It said, hey, expected missing gender, but was missing command line argument. Okay, so this is cool. So now I want to start thinking about how I approach parsing my command line. So let's see here. Well, I want to basically get a string. Well, the first one is name. Well, you know, actually, let's you know what? So missing gender. I don't know. Let's not do that. What do we say that this was? Not enough arguments. Not enough arguments. So really, what do we say? If args.length is less than, what do we decide there? Were 1, 2, 3 three required arguments, then, well, just this, I guess. It's nice and easy. So actually, instead of, so now if I run this, so you expected not enough arguments, but was missing command line arguments. Oh, and there's a print line, isn't there? So I don't want equal to, I want contain string, and then missing command line arguments. Run that. That passed. Everything else, let's run everything else. All those passed. So I did red, green, time for refactor. So I've got a magic string. So let's turn this into a constant saying missing command line arguments. And that way, it's that way if I change something, so I mean that way I can say, let's use that here. Oops. Import static constant from student. Yes. And let's see here. And then this one. Nice. Now I'll run everything again. Oh, and notice when I ran everything, the Dave student, I'll let you go again. The Dave student is written to standard out. It has a gray go special sign here with the slash through it because it was ignored. Sorry, it was disabled. But all the other ones passed. Okay. That was some nice that's nice refactoring. Okay, cool. And let's see here. And I guess then we would expect the same thing for missing missing GPA. Missing GPA, and then with Dave, and then other. And this one's probably going to pass right off the bat because the way we implement it, and that's okay, right? I mean, something like this, I could have said, hey, if it's less than, 2, then we could have watched that one fail, but that's okay. I think y'all are starting to get it. Okay. There is another refactoring that I kind of like to do. I have this invoke main student.class all over the place. I really don't need it. Let's see here. And so then what I'm going to do is I'm going to create a new method. I'm going to call it invoke main. And let's replace all this stuff. Good, good, good. And here I'm going to give it a variable number of arguments. And then I'm going to pass that on to this invoke main. And then I'm just going to be able to get rid of this. So I don't need to type that student.class because all these tests are going to invoke the main method of student. So I really don't need that. I think it just makes it a little easier to read. Okay, some nice red-green refactor. Let's run all of the tests again. Nice. Okay, so I ran my integration test. I should probably just run my unit test just in case. I didn't change anything. At least I don't think I did. But it's really easy to find out. Just run them. Good. Everything still passes. Yay. Okay. So now I am going to commit these and detect when there are not enough command line arguments. Okay, so let's see here. I think we have, actually, I'm going to mark these as implemented by like shading them in some background. Which one is the shade? Background color, we'll just call them light green. How's that look? Yeah, that looks okay. We've done that one too. Okay, not a valid. Okay, great. We got a bunch of them that are invalid GPAs. Okay, so let's see here. Okay, now we got to figure out which one is the. Okay, we got to write our test first. And this is void invalid number is not a valid GPA. I'm going to start with the foo test case. So I am going to let's see here. Dave, other, and then foo. And I want to have the string contain string. Well, actually, wait a second. I'm going to call that invalid GPA. And then I'm going to call this error message. I'll just call it error. And then error contains string invalid GPA. And I also expect that it'll contain the string is an invalid GPA. Oops. So this is equal to 1. Okay. So now if I run this test, I expect it will fail because it said, hey, I was expecting a string that contained foo, but it was actually in the empty string because it's true. In this case, nothing is written because it's greater than 3. Nothing's written. Okay, cool. So the next one is we got to test this GPA. Okay, so GPA string will be args. Let's see here, 0, 1, 2. So that'll be args2. And how do we test that whether or not a string represents a valid number? Anybody remember? Regex matches. Okay, that is a good. That is a way. This is a floating point number that regex. Yeah, it's possible. Amila is like, okay, is there an is num? Close. Yes, actually there is. So GPA is a double in Java. And so then we say to convert that, we say use the double dot parse double and the GPA string. So that we do it that way. Okay. Convert the string to a float and test with an if. Not in Java. Well, we'll talk about the Java way of doing it. Okay, so now we have our GPA right there. Let's rerun and see what happens when we call double.parseDouble with this bogus string. I got main method should not throw exceptions. Number format exception for input string foo. Because that's true, it tried to parse it and it threw a number format exception. Okay, so what do we need to do here? Well, when we call parse double, we need to catch the what is it complaining about here? Probably don't do anything with it. Yep, we need to catch a number format exception, and when we get that number format exception, we are going to say system.error.println, and we're going to say GPA string is not is an invalid GPA. Okay, let's run this again. Oh, assertion error. Yes, it expected the exit code to be 1, but it was null. Okay, well, I forgot because I forgot to call system.exit. Let's run it again. Nice. Okay. That's cool. Okay, so that one runs. Let's run all of the tests for our integration tests. Yay, we got it. Okay, everything's running so far. So that was the red, and now it's green, and now it's refactor. I see some duplicate code. I see some system.error.println and exit, and the same thing right here. So let's put these 2 lines of code into a method. So then we'll just say this is going to be the, we'll say it's the message. And then we will create a new method here, and we'll call it print error message and exit. I want to replace both occurrences. Thank you very much. Nice. Okay, and it's telling me that this is redundant, so I can inline it. There you go. Nice. Okay, I refactored. Let's run all my tests again. Nice. Okay. So let's commit. Let's see here, 8 o'clock. I need to get going. Okay. Issue an error when the GPA is not a valid double. Okay, let's see here. What else we got? Oh, now we have these ones right here. Oh, sorry, we should do this. Mark this one as implemented and green. Now, these two cases are interesting. Now, ultimately, what your main method is going to do, and maybe it's something that we should implement. Actually, you know what? I've got an idea. You know how we disabled this test right here? What if we just made this pass by hard coding in some values? I don't think there's anything wrong with that, really. So in this case, oh, well, actually, I kind of do know what the problem with that would be, because, well, here's what we want to do. Okay. Yeah, you know what? I was going to say, oh, why don't we put that all in there? But then again, we don't have a way of this toString isn't even close to being implemented yet, right? So maybe actually. So let's go ahead and implement that and see what happens. So here's kind of ultimately, I want to start sketching out some more of the implementation. It's okay, I guess, to implement it this way. Let's just see here. So string, actually, no, sorry, I don't want to do that quite yet. I'm not quite ready to implement those particular cases. Why am I not ready yet? Actually, I could totally do that. Let's just do that. So I think there are a couple of them, though, that are kind of implied here. There's a couple test cases that I want to write that are implied here, but I want to call them out specifically because I want to start creating my student object, even though not everything is implemented yet. So I want to write an integration test that says student name is written to standard out. Oops, out. And so then I want to say, hey, listen, when var result equals invoke main with let's just have, well, let's just make a Dave. Let's not. Well, yeah, so Dave, and then let's just have all that stuff. Let's use all of those, but I just want to test the name part. And I want this to be the student name. And when I do this, I want to say assert that the text written to standard output contains string student name. And I want to, I'll say this should be get exit code equal to 0. So I'm not asserting the entire value of the toString. I just want to get Dave in there. I just want to get the name in there. So let's see what it takes to implement this. Okay, I was expecting a string containing Dave to be written, but the only thing that was written was the empty string. Okay. Now, okay, we need to start implementing more of this. So let's see here. We want to say that the name of the student is going to be the first argument. And because ultimately, here's what we want to do. We want to have a student, a student equals new student. And this thing takes, well, first of all, the name, and it takes its classes. We're not going to have any of those yet, so let's just do that. The GPA, you know, we're not, I guess we kind of do have a GPA. So I don't want to implement that quite yet because I don't have a test for it. And then gender, we're going to hard code this too. So basically, we're going to hard code everything except for the student name. And then we're going to say system.out.println student.toString. And then we're going to say system.exit 0. IntelliJ has this in gray because it is an unnecessary toString. Okay, fine. Remove the redundant toString. Yay. IntelliJ is happy. Okay. So now if I run this, what do I get? Okay, expected a string containing Dave, but was they. Well, that's true, because what does our toString method, let's go find our toString method. All it does is print the gender pronoun. Okay, well, so then now we need to implement the functionality that puts a student name into the toString. Now that functionality isn't going to be inside the main method. It's going to be inside like the student constructor, and we're going to change the toString method. So I want to put that test in the unit test, because that is testing not the main method, but it's testing the methods of the student object. So I'm going to put that here. And then I'm going to say toString contains student name. And okay, this is going to be pretty easy. I'm going to say student. I'm going to call it Dave. And it's going to be create student named Dave. Actually, I'm going to call it Dave. I'm going to put this into a student name variable. And then I'm going to say assert that Dave.toString contains string student name. Going to run that test. And I get actually the same error because it's invoking most of the same code. It's not doing it through the main method. It's doing through creating the object directly, and that's fine. That's exactly appropriate. That's what a unit test should be doing. And so, okay, let's implement this. So how are we going to implement this? Probably not too hard. I'm going to say this.name equals name. And, oh, actually, sorry, I don't need to do this because I guess I already inherited that from super, didn't I? Right, so super, oh yeah, it sets the name there, so I can just say, I guess I can just reference the field. Is there a get name? I can't remember. Let's just find out. So toString get name. Yeah, it has a get name. That's nice. There's more here, but just for the time being, I'll put a space between the two. Maybe that's all I need to do. I'll run the test, and that worked. Excellent. Now, if I run my integration test, is this sufficient also? Hey, that worked. So this is a very common thing, right? You start, unit testing is usually about putting together classes and stuff, but you need to consider the larger context. The larger context is what the command line does. So we brainstormed a bunch of cases, and you go back and forth. You implement some integration tests to get the main method to a point where it's like, oh, now I need to go work on the toString method some more. Then you go back to your unit tests to work on that. And the reason that you do that is so that you have the finer grained unit tests to cover all the like kind of the fine grained operations, and then you use your integration test to do more of the coarse grain. Cool. Okay, let's iterate that, or let's check that in. So include the name of the student in the toString output result. Okay, now I'm ready to go back to these two tests right here. And the reason that I hesitated on doing those next is because of the following. So here we're checking whether or not this is an appropriate GPA. Now, where should that logic live? Where do you want to validate that a GPA is between 0 and 4.0? Where in the code? Is that something that is in the main method, or is that something that, and it should be therefore exercised with an integration test, or is it something that is in the student class and should be exercised with a unit test? What do you think? Does that belong in a unit test, or does that belong in an integration test? Susan votes for student class. So is Amila. Where's it? Yeah, Amila. Unit test. Yes, I think unit test is the right one. So, and the reason I say that is because the GPA is passed in as a double right here. So it makes sense to, yeah, I mean, I think it makes sense to pass it in, to do the validation here. But you know what? It won't hurt to at least write integration test for it also. So we want to say, let's see here, too large GPA is invalid. So here, let's take this one. And now the invalid GPA is going to be what we have. We had 4.01. Right? So now if we run this, it fails because nothing was written to standard error. That's good. So now let's go and implement that. So that's why the unit test for it. Actually, this is kind of an interesting case because what should happen? So too large GPA. What should it do? What should happen? What are some of our options? I mean, what are some of the options that we considered when we were trying to validate the gender that was passed in? And what did we end up doing? Well, ultimately, what we ended up doing, if you recall from get gender pronoun, is it should give the valid. Oh, right, it should give the valid range. That's probably what you should tell the user. But we decided we were going to validate the GPA. Maybe that's something we should do here. We should just write a. Well, actually, what we'll end up doing is writing a method. Let's call it validate GPA. Geez, spell validate GPA. Right? What should this method do? It should probably throw an exception, just like get gender pronoun, right? When you get gender pronoun, when you don't have a valid gender, it throws an unrecognized gender exception. And so probably it should probably throw an invalid GPA exception. Okay, well we know how to write one of these, right? It's just like this thing right here. But now we have we'll have a double GPA equals 4.01. And instead of an unrecognized gender, we'll have an invalid GPA, valid GPA exception. And this will be student.invalid GPA. And we will create that class right there. Oops. We want this thing to extend a runtime exception. And let's see here, as far as saying it can be static, which it can. Okay, and so then we want this invalid GPA exception there. Oops, probably want to do a static import. And we want to do, let's create a student with a GPA of, this would be, we should call it invalid GPA, and then rename it to be invalid GPA. Create student with GPA. And then what's the other create student methods like? There we go. And then invalid GPA, that is not a string, so we need to turn it into a string by using string value of. Okay, so let's, I just wrote this method. Let's take a look at it. First we have, okay, so we say, hey, listen, we're going to create a student with an invalid GPA. And when we do that, we expect that an invalid GPA exception will be thrown. And we expect that the message associated with that GPA contains the string invalid GPA. So let's see here. Let's run this test and see what happens. says expected an invalid GPA exception, but nothing was thrown. That is true. So now let's implement this thing. So we'll where's that validate GPA? Great. So if we say if GPA is greater than 4.0, then throw new invalid GPA exception. Okay, let's run it again. Cool. It's now failing for a different reason. Expected a string containing 4.01, but instead was null, and that's true. We did not set the message associated with the exception, so we'll just throw that one in there. And so we'll send it to the exception, and we'll say, yes, please create the constructor for that. And then we'll say super dot invalid GPA. We'll run it again. Yay, and it passed. Okay, great. Now we also add that test in student IT. Let's run this test again, and let's just see what happens. Oh, interesting. So expected a string containing 4.01, but was empty string. So it didn't seem to take. Let's figure out why. So let's now go to the main method. Aha. That's because we are always passing 0 into the GPA. So, okay, now we need to put in the GPA, not the GPA string. So we need to put, we want to assign this the value of, oops, we need to assign this the value of GPA. GPA is not available here because this is inside a try-catch block. So I'm going to, oops, can I split into declaration assignment? I can put it up here. Oops, and then move it up here. And now it can find it, but it's saying that GPA might not have been initialized, which is true because the compiler doesn't realize that this method is going to always exit the VM. But if I say return here, then the compiler knows that all the code paths that lead to this usage of the GPA variable will have a valid value for the variable because either it successfully gets parsed and assigns a value here, or the number format exception is thrown and the code returns before it ever gets to this point. Okay, nice. So now let's run it again. And now main method should not throw exceptions caused by invalid GPA exception. Oh yeah, look at that. It threw the GPA exception, the constructor threw the GPA exception just like I expected, but it didn't, but nothing caught it. So now I need to catch it, I guess. Okay, fair enough. I'm going to break this into a declaration assignment because I'm going to say try here, and I'm going to, when I create my student, now I'm going to catch the invalid GPA exception. And when that happens, oh, you know what? Actually, I don't need to do that. I'm just going to put this back up in here, I guess. And then I'm going to move this down here, and then I'm going to join declaration assignment. There you go. Okay, so now when I catch the invalid GPA exception, what do I want to do? Well, I want to say system.error.println. I want to have the GPA in there, and I want to say is an invalid GPA. And I want to, actually, I don't want to do a system exit. Instead, I want to say print error message and exit. And let's go from there. See if that works. Yay, test-driven development. Okay. Hey, while I'm here, okay. So I've got a couple more things to show you, and then we're heading towards a break. Don't worry, because I know I've been talking a long time. Okay, so nice. Let's see here. Oh, print error in a message and exit automatically exits with a 1. That is correct. So if we look at that method, what it does 2 things. It prints an error message and then it does system exit with a 1. Yep, that's what it does. Okay. So all night I've been writing tests, and yeah, you'll notice. Okay, so I did red, I got it green. And one of the things that I do as I write code is I run like the new tests that I added, but then I also go back and I make sure that all of the tests in the program. Oh, something broke. Dave's student is ready to standard out. Oh, look at that. Okay, right. This is the one. Oops, did I unignore this one? I meant to disable this one. Right, because that is the, yeah, that's like the big one. Did I check that in? Oh, very interesting. I think I checked that in. Not what I intended. Okay, okay. So I've been writing tests all night. And good, I just found that I broke something. And so this is why you have to run all of your tests. I'm going to run my integration test. I'm going to run my my unit tests. Great, and I think everything runs. Now there is one other way to run all of your unit tests and all of your integration tests, and that is to do it from Maven. So if I do a Maven W clean verify, this will run it from Maven, and this will run all of the tests, all of the unit tests, all of the integration tests, and this will make sure that none of the changes I have made have broken anything. And the thing I like about running using Maven is that it's sort of like it just does everything for you. So if you know that this is good, everything is working. Okay, great. So it runs from the command line. It runs from IntelliJ. I think it's ready to commit. So I am going to actually I'm not going to commit it just yet because of the following. So I just ran it here on my local machine from the command line and from IntelliJ. And then what I do after I run my test is I commit my code and I push it up to GitHub, right? You've been seeing me do this all night. Now, every time I push it up to GitHub, changes are coming in. And it would be nice to validate that those changes not only work on my local machine, but also work in a very clean room environment. Right, this is just a good thing. Right? Sometimes your local environment has something configured, which is different from your coworkers or different from like a brand new fresh, check out a brand new fresh installation. Well, there's something called continuous integration. So the whole idea here is that when code is committed to a shared repository, or maybe ideally before code is shared with everybody else, you want to make sure that code doesn't break any of your tests, because the tests are there for a reason, right? They're there to find errors in your code that you've interjected. And so then let's go to let's go find the right GitHub repository. From source code, and we'll look at my Portland State Java winter 2022. Nice. So continuous integration servers. Continuous. Do I have integration? I don't have much of anything written here about it. Okay. So continuous integration builds your project automatically whenever the code is changed. GitHub has these things called GitHub Actions. Oops, we'll go top here. And GitHub Actions are configured, and you don't need to know this, but I'll show you where it's configured. It's configured in these what are called GitHub workflows. And basically what I do is I say, hey, listen, whenever code is committed to my main branch, please go through and run Maven verify with that latest with that latest source code and make sure that nothing's broken. So basically what it does is it says, hey, listen, go check out the source code, set up a JDK, and I'm running it both with Java 11 and Java 17. so do two jobs. One, run all the code with Java 11, run all the code with Java 17, and if something breaks, let me know. And so so every time I've been checking in, basically like here's all my check-ins tonight from like 2 hours ago. Every time I check in, this stuff gets run. And what gets run? Well, you can see like for both JDK and JDK 11, JDK 17, it gives you this little thing, and so you can say, hey, build a Maven project. And now here is the output from building my Maven project. It downloads, half the internet with all the dependencies and stuff. But if you go down to the bottom, you can see that it ran everything successfully. Your student project, the airline project, and the cones. It's the same thing as just running everything, running a Maven clean verify from here. And what this does is it just, it runs my tests automatically and detects when things go wrong. Well, as it turns out, because I forgot to disable that test, the last change I made, it has a red X next to it because, let's see here, let's look at JDK 17. It had a failure during this build Maven project step because it said, let's see here, where is the error? There it is. Dave's student is written to standard output. That should not have been re-enabled, and it failed. This is a good thing, right? And actually, there's now an email in my inbox saying, hey, you broke your code. So, oops. So now what happens when I go and I commit these changes here, when I added that new test, so this was, handle a GPA which is greater than 4.0. So when I push these changes, push them to GitHub, there they go. It detects that I made a change. It kicks off a new job and tells me that it's running. It tells me, hey, there are 2 jobs. We'll follow the JDK 17 one because it's probably faster. Here it is, building the Maven project. You can see all this stuff. So this is happening, all being built on a server that GitHub runs. This is a really great service that GitHub offers. It basically makes it really easy for anyone, including you, to get all this validation. As a matter of fact, some of you might have noticed if you started working with your Maven repositories that as you're making changes, you might be getting these feedback emails from GitHub saying, hey, wait a second, you just checked in some code that broke a test. Actually, has anybody experienced that yet? Because I believe this should all work pretty okay. Yeah, people here in the classroom, some of you have also. Great. This is, I think, a really awesome thing. Because look what I just did here. I inadvertently broke one of my tests. I re-enabled something that should have been re-enabled. I didn't catch it before I committed the code. I committed the code, but GitHub told me. Right? GitHub found my error for me. This is great. I welcome our new robot overlords. If they're going to tell me things like this, right? Way better than Terminator Judgment Day. Oh, look, in that, in the time I'm, making jokes about movies from the 80s, it has run all of my tests for me. It's validated that all my code is good to go. And not only do I know this, but anybody that looks at my repository can find this out, because when you go to like the main page here, there's this little green check mark next to this commit, saying that this commit was healthy. And so this is really important information to know. It tells you that all your tests are running fine, right? And so Patrick also said, oh, one of my builds failed last week, right? And you probably checked, clicked on the well, I don't know if you clicked on the email or whatever, but this is what it's there for. And this is important because of the following. As a matter of fact, let me just do this one last thing, and then we'll take a break. Yeah. This will finish off this section nicely. Okay. So tonight we've been talking about testing. We've been talking about unit testing. We've been talking about integration testing. And while this stuff is really great, it's also relevant and required for your projects. So, when I was your age, when I started my career, the conventional wisdom was that development and testing were 2 separate activities and ought to be done by 2 separate people, and never the twain shall meet. Oh my gosh, you're like, we will end up with terrible software if the same person that, if developers wasted their precious time to write tests. Instead, we should pay someone else to do that and pay them a lot less because, oh, they're just testing, they're not developing. And this is ridiculous in hindsight, and it had a lot of downsides. first of all, there were super long feedback loops between the time that you wrote the code and then time that you validated the code. And this happened to me early in my career, where it's like I wrote something and I thought I did it right, and then someone's like, well, no, you missed this case over there. I'm like, I haven't touched that code in 6 weeks. I don't remember what I was thinking. I was probably drunk at the time. And so then, I had to go through and just remember all of this stuff. Well, as we see today, I get feedback. Either I find out myself within seconds or within minutes after I check it in. I find out that I've broken something. Also, because people didn't agree up front on how the software was supposed to behave, a lot of time was wasted arguing over what should have been done, as opposed to agreeing, well, here's what we're going to do. Let's go do that and validate it quickly. And also it resulted that people who focused on quality were reviewed as second-class citizens, and this is so wrong because, as we saw tonight, there's so much value in just brainstorming test cases and talking amongst ourselves to figure out, hey, what is this project going to do? And it's not just the one person who's writing the code. Even if it's multiple people writing the code, it's not just the people who are writing the code. People with a testing mindset are invaluable to organizations because they're thinking big picture. They're thinking like the stuff's happening on the outside, and then other people can then focus on what's happening on the inside. And so luckily, certainly in the course of my career, we think of things differently, or rather, many people think differently now about about how software should be tested. I think a big thing that changed this was introductions of frameworks like JUnit that made it super easy to write tests. And hey, it's coding, right? And so people like to, developers like to code, and so others write tests too. And certainly test-driven development was born out of this, ease of use, or making it very easy to write tests. So I have evangelized testing and test-driven development for many, many years. But it was just sort of like, hey, you should do this for the course. And then I realized, like, well, no, I want you must do this for the course. And so then, the way I force you, for lack of a better word, to write tests is that I measure that when I grade your projects, a portion of your grade is based on the amount of test coverage that your automated tests give you. So I use a tool called Jacoco for Java code coverage that runs your tests and then issues a report saying, hey, how much of the code was tested? So if you run, and this is the way I'll run it, so if we go to the student and we run maven-pgrader, which is for the grader profile in Maven, you say clean and you say verify. This will, Maven W. This will, clean the code, build all the code, run all of your tests, but run all your tests in a mode that is instrumented to gather code coverage information. It does a lot of neat stuff behind the scenes to measure which lines of code are exercised by your tests. Everything passed here. It said that it analyzed the bundle student with 3 classes and all the coverage checks have been met. Well, that's very nice. Although it isn't at all surprising since I use test-driven development. I didn't write any code until I had a test for it. And what this does is it creates some reports here in the. Sorry, I just need to go find it. Maven site Jacoco index.html. So if I open this up in the web browser, I'll make it a little bigger. It creates this nice report that lets you drill down into all of your classes, and it tells you which instructions and which lines of code were covered. So as we can see here for some of these, all the lines of code, but here for like the main method, for instance, it's saying that these calls to print error message and exit weren't covered. Well, I believe they actually were, but it doesn't get it right. It doesn't get it 100% right, and that's fine because all you're required to do is achieve 75% of the JVM instructions. Essentially, it's 75% of the lines of code of your project, and every class that you write must be exercised by an integration test. If your unit test and integration test, if your automated tests do not provide sufficient coverage, I'll deduct up to 1 point from your project grade. And this is the the stick that I use to encourage you to actually to force you to write automated tests for your code, because trust me, it will make your code better. It will make your grade a lot better because you will have exercised all of these different scenarios. And as you build your project, you will have this suite of unit tests and integration tests that you've built up over from the previous projects that will then make sure that the fundamental functionality of your code doesn't break as you add more things. Okay. Any questions about testing? Now, you've seen a lot in the last hour, and we've covered a lot of things. We still got a couple of things. Sorry, this was a long one. But any questions before we take like a 15-minute break? Nope. Okay. Cool. Let's take a 15-minute break. We'll come back. We still have a couple of really important things to cover, including your project 2 and some things that you must do in order to be able to submit your projects. So take a break, get a breather. I'm going to get some fresh air, and I will see you back in a little bit. Okay. We've got a couple more things to cover. They're really important because it's all about requirements for your projects. We're going to talk about documentation requirements, how to submit your projects, and then we'll cover project 2. So documentation. So especially when you're students, being able to talk about and reason and describe what you're doing in words is very important. Actually, it's actually really essential as professionals too. Whether you're talking to your other your colleagues, whether you're communicating them in chat or where you're exchanging emails or documents or capturing what you're doing, you got to be able to write about technical topics, write about your code. And I found that it helps to write about it before you do it and as you do it. And so then there are a couple of exercises that we do in this course to give you practice at doing that. The first one is called a plan of attack. So a plan of attack is an email that you send to me that is a couple of paragraphs of written text, of English text, that describe how you'll implement your project. It's not code. It's not pseudocode. It's really about, hey, what are the classes? What do they do? How do they interact with each other? Your POA is worth 1 point of your grade, and that's why in the project assignments, you'll see that the whole thing is worth 6 points, and there's that first footnote which says 5 for the code, 1 for the POA. And so the plan of attack is worth 1 point of each of your project grades. Please send this as a text form as the body of the email. Please don't attach a PDF. I don't want a Word document. Just write it in the email. You can draft it in something else, in a Google Doc, and then paste it in. That's fine, but just send me a text email, please. It makes it faster for me to grade. The POA is due 3 days, so 72 hours. So the project's before the project is due. So projects are due Wednesday at 5:30. That means that POAs are due on Sunday at 5:30. And I believe I put Canvas assignments for each one of those, so it's on the Canvas calendar. Please email to my whitlock@cs.pdx.edu email address with letters POA in the name, POA in the subject of the email, and that will put it in a folder that I look at on Monday to grade all of your POAs. But please, if you have something important for me, do not put the words POA in the subject, because then it will get routed to the mail folder. Even though you have a couple of late days for projects, you don't have there is no late POA credit. The whole idea of a POA is that it's another forcing function that makes you start the project at least 3 days before it's due. So here again, I want to discourage you from doing things at the last moment. So that's the plan of attack. Any questions on that before we move on to other forms of documentation? And there's also some documentations provided in and with your code. So, documenting your code as you go is an important skill, and one that needs to be developed, just like any of your other software engineering and coding skills. For Java, there is this convention and a tool that goes with it called JavaDoc for Java documentation that will create documentation from special comments inside your source code. So you're required to have a JavaDoc comment for every class and method that you write. And I, via the grader, reserve the right to deduct up to 1 point from an assignment that isn't well documented. So here again, we're looking for lots of documentation for your code, which is your way of explaining what it is that your code does. So a JavaDoc comment should describe the functionality of each class and method, and I encourage you to use the tags like @param, @return, @throws when you have methods that apply there. Please check out JavaDoc at this URL. And actually, let me show you some stuff in JavaDoc. We'll go into more of it shortly, but the way I assess the JavaDoc, well, let me show you what JavaDoc is first of all. So if we look at our student class here, you'll notice that the student declaration is preceded by this special comment that begins with /** and ends with // It says this class represents a code student. Similarly, your constructor for the student class has a description, it has a special comment that says creates a new student, and then it has these @param for name, classes, GPA, and gender that all describe what these things are. These are JavaDoc comments. And there's this tool called JavaDoc that will parse your source code and extract these comments, and then you can do something with it, like format into HTML or PDF or whatever. In the case of in the case of the class, what I'm going to do is I'm going to run a command, which will be maven-p grader JavaDoc. And when I do that, it scans the source code, it will run the JavaDoc tool, and it will generate this text output that extracts the JavaDoc for your class. So here it is for your class student. Here's the JavaDoc. It represents a student. Here's the constructor. Here's the name, classes, GPA, etc. And this is what the grader is going to look at when they evaluate the quality of your JavaDoc, is this output here. So if you want to make sure, so for instance, I've got, here's like a private method without a JavaDoc, and I probably should say so, which probably should have something, same thing with gender pronouns. So I should go and add some things there, so that it is better documented. But anyway, that's how you can do that. Oh, actually, geez, I should definitely add some comments for these classes here. So anyway, run this command, and actually, I should add this to the PDF, shouldn't I? I will try to remember to do that. And actually, if someone could like send me an email or send me a Slack or something, reminding me to put this command, this -p maven w-p grader JavaDoc, that would be helpful to you and future students. So that's all about JavaDoc. We'll see a little bit more about that next week when we talk about building Maven sites. When it comes to writing your Java code, I would encourage you, although it's not something I really enforce, but I would encourage you to learn about the standard Java coding conventions. This is, how to format your code, where your braces should go, how many spaces you should use, all sorts of stuff like that. This makes it readable by others, like me. A number of you have shared your repositories with me. Thank you for doing that. I might have to look at your code. And if you're going to learn how to write Java, you might as well learn it the canonical way. Now, something else which is relevant to your projects and to your grades is the -readme flag. So all of the command line projects have an option called -readme, right? It was mentioned here in the assignment last week. There is this -readme and prints a readme for the project and exits. So here's what that thing's all about. So the readme is a brief, concise, and nicely formatted text description of what your project does. And it should say, hey, who you are and which assignment it is, things like that. This is, another chance for you to describe what it is that your project does and how to use it. Although the README should be more than just command line usage, it should have a little description of what the project does. And note that when the README option is present, all your program should do is print the README and exit. No command line validation, no creating objects, nothing like that. Just say, oh, look, I'm printing the README. That's all you do. Yep, and that's what the README is all about. Now, when it comes to implementing the README, you can, it's a bunch of text. You can hard code that text into your Java code and print it out. That's absolutely fine. But over the years, people have asked me, hey, can I just put that in a file and it would be much easier? And I said, sure. And so, and then I said, you can use something called a Java resource. And students are like, what's that? And I'm like, well, let me show you. So inside your airline project, the one that was created from the create project one script, there, over in your main code, there is Java source code. There is some Java.doc stuff. There's also something called resources. Now, resources contains a file called readme.txt. Now, in Project 2, you'll start working with files, and resources are technically files, but they're a little different from the files that you'll be reading and writing to. We'll get to that in a second. The whole idea is that a resource is a file that is bundled with the application and is used by the application. They're read-only. So it's things like icons for your user interface, or let's say you have a bunch of you want to localize or translate your application into different languages, different spoken languages, and so then hey, if I'm running in France, I want a different day for Monday instead of Monday, things like that. Now this is all explained in the core API lecture. There is a let's see here. I think it's a project 1 test. Yes, there is a project 1 unit test. Java project 1 test here that uses some code, and this is the code that I recommend that you follow for working with your READMEs. So you can call this piece of magic, and you can go read, watch the lectures and learn exactly what that means. To get the readme.txt as a stream, and then you can read it in and display it that way. This is actually going a little bit beyond what project 1 is usually about, but it's much easier to put your README in a text file than it is to try to hard code it into your source code as a big old string that's there in your source code. But the choice is completely up to you. You don't have to use the README. It's just it's easier. It's a little bit more advanced, and it'll probably save you some time in the long run. So here again, if I run this code, it'll be able to load that README and verify that yes, it contains a string. This is a README file because that's exactly what is in that string. And you can then use this code in your main class to read the README. So, oh yeah, something else. If you're going to put the README text into a file, it has to be a resource. It has to be in this directory. Don't assume that there is a file called readme.txt in the working directory or someplace else. It has to be all there, and this is stuff that you might you'll be able to see as you work on your project. So, any questions about these documentation requirements for your projects? Okay. So, project 1 due next week. So you're writing unit tests for it. You are writing documentation for it. You've developed your application. You've brainstormed all of your integration tests. You've implemented a whole bunch of tests for your command line. Everything's working. You're like, okay, it's ready. Or maybe it's almost 5:30 on Wednesday night. It's time to submit. Here's how you submit. So let's see here. Submit.sh. Oops. Okay. For many years, so many years ago, I wrote a tool that is a Java program for submitting the code. What this tool does is it looks at the Maven project, and sorry, someone's joining. I need to Put them in. What the submit tool does is it looks at the source code for a project. It will get all of the appropriate source files. It'll zip it up and it'll email it to the grader. This is actually really important to me because, like I said in the first day when we were talking about that survey.sh, which by the way, almost everybody has run. If you haven't run survey.sh, please do that as soon as possible. The submit script also is key to taking the toil out of grading, so the grader can focus on giving you feedback instead of extracting submissions from emails and moving files around. I'm trying something new this term. Instead of running the submit script directly, I wrote a script to do it. I think this will further take out some of the error-prone steps that have tripped students up in the past and cost everybody time. The submit script, just like the survey, can only be run on the PSU machines. And so then what I recommend that you do is what the survey script does is it first runs clean verify on your code just to give you an idea of how it runs. So let me just show you what's going on here. So let me just run the script for you. So yeah, I think I'll do. Actually, do I have it here? I think I do. CD Git Portland State Java Winter 2022. Excellent. I've got my code here. I am going to actually let me set up my keys. Let me type my passphrase wrong. There we go. Let me do a git pull. Got a whole bunch of changes. That's cool. Okay, so let's say let's go my airline, and I will just let me make sure that everything runs. I'll do a Maven clean verify. Run my airline. So let's say I've implemented everything. I'm ready to submit it. I do one last check and make sure that everything builds here on the PSU machines. Yay. Okay, I go up one directory and there is a script called submit.sh, and I say I'm going to submit project 1. So it goes and it runs the airline code. It goes and it first does another clean verify just to make sure that everything's going okay. So it's running the test. It's doing all of that, and then sorry, kind of goes up the screen. Yes, the build was successful, and it's like great. Here's all the code that you are going to submit. Oh, and then it asks you one question. This is a new question. Last week, somebody, and I think I'm almost certain it was Susan, had a great idea. She's like, hey, I'm starting this new course about Java. You say there's a lot of time, programming, a lot of time. How much time is it going to take? And I'm like, I've got no idea, right? You can go back in the recording and probably hear me say, I've got no idea. And so I thought, well, what if you all told me how much time it took you? And so then there is a completely optional question for you to answer when you submit. And that is, hey, about how many hours did you spend on this project? I'm looking to gather data here. And so I want to be just crystal clear on this. The answer to this will not impact your grade in any way. I will not share individual responses. Yours will be, please consider it to be confidential. I will know, but it's not shared with anybody else. And all I'm going to use it for is providing it as input into aggregate information, such as like on average it took this many, or like, hey, here is the here's the min, the max, and here's the upper quartile, and all sorts of stuff like that. I'm very curious because I have to admit I don't know how many hours. And so then if you would like to, please feel free to enter how many hours you spent on this project. And so hey, I'm going to say, let's say it took me 6 hours. I have no idea if that's reasonable or not. And then I'll say, great, thank you very much. Do you wish to continue the submission? And the answer is yes. And so what this will do is then it will create a zip file and email it to the grader. It knows who you are because it takes the information from that me.xml file that the survey created. And so then it knows what your email address is, it knows what your ID is, all that stuff like that. And And so then this is like the new way of submitting. I hope it's a lot easier than the old way. I really hope it's less error prone. So then use this survey.sh script. It's super easy to use. You just have, you say, sorry, it's a submit.sh. You say submit.sh and then the name of the project. This is project 1. You can do 1, 2, 3, 4 and all of that. You will also receive an email saying that your project was submitted. Any questions about the submission process and what this script does? Nope. Okay. Now, as I said, the submit.sh script is a brand new thing this term. And over the weekend, I realized that there were some bugs in it. I think what was there on Friday night was completely sufficient for project 1. But I realized, like, oh, this isn't going to work for the cones, and oh, this isn't going to work for the for like project 5, the REST API project. So I made some changes, and I made some bug fixes, and I made all of those changes and bug fixes in my Getting Started repository. So as you can see, if we look at the if we look at the submit.sh, and then we look at the history of it. I thought I had everything all set on January 1st, but then, oops, on the 9th, I made a bunch of other things. Now, I created, and many of you created, I'm sure, your own repositories before January 9th. And so now if I look at my submit.sh, and I look at the history here, oops, mine end on January 1st. I don't have all of this stuff from January 9th. And I bet if you all did the same, many of you would be like, oop, I don't have the stuff from January 9th. And you want the stuff from January 9th. So first of all, sorry, I apologize. It's brand new. I thought it was fully baked. It wasn't. Oops. And so what I want to do now is I want to walk you through the process by which you can get these changes, these upstream changes, from my Getting Started repository into your repository for this term. Now, luckily, this is the kind of thing that Git is super good at, right? So that means, Git is a distributed version control system. It can do this, and I think it'll work pretty well. Although, you know what? I didn't validate it. So hopefully it will, sorry, upstream. Now, if you search for the word upstream in the README, you'll come to this section. So you've made your own copy, your own clone of my Getting Started repository, and I've then made some changes in mine that you don't have. And so here's what you need to do. So go to the top level of your directory, and here I am. This is on the left. It's the checkout on my local machine. Over here on the right is the PSU machine. So over here on the left. Oh, and let's see here. Just for yucks, I'm going to do a git log of submit.sh. And as you can see, this only has January, the one from January 1st. And over here, I guess that's sort of the same thing. Yep. Okay. So what do you need to do? You need to do the following. You say git remote add upstream. So the whole idea here is that you have your repository, and you're going to say, hey, listen, there are changes in another repository that I want to be able to pull into this repository. So I'm going to say git remote add upstream repository for Getting Started, which will be this one. I'm just going to copy the URL from here. You can use the one HTTP URL. I always use the SSH keys one. So this is basically saying, hey, this repository has this remote repository. We're going to call it upstream, and it's going to be the Getting Started repository. And now you can say, hey, pull any, go find any changes that are in the upstream repository that aren't in this one and pull them into mine. And then if there's any change, and then like merge the changes into my repository. Gosh, I hope this works. Nice, it did, and it's telling me, hey, would you please go ahead and merge it? This is the commit message. That's great. So I will just write this in VI and commit it. And great, it's telling me some things. So I made a bunch of changes to the README. I knew that. I renamed a couple things, create project 4 to create project 5, and I made some changes to submit.sh. Good, this is exactly what I expected. And now that I've got them here locally, I need to push them back to, because actually if we look here, if I reload this here on GitHub, it is still the January 1st because I haven't pushed those latest changes. I'll push them now. Now when I reload this, oh good, my repository, just the same way yours would, the one for winter 2022, now has these changes. I can now go, and actually now if I do a log of submit, I see I've got the ones from January 9th. Now I can do a git pull over here on my PSU machine. That will get those same changes. And now if I do my git log on my submit, I've got the latest one. Okay, this is good. I will submit my code again just to make sure it still works. The script still works. Something was red there. What was that? Oh, the coverage checks weren't met. Well, that's interesting. Oh, yeah. Oh, was that new? I'm not sure. Okay. But you would have to fix that. I don't. Let's say it took 8 hours to do it. And yes, I wish to continue. Okay, I think that was all right. Anyway, so that's a neat little lesson in Git and GitHub, and it's something that you have to do in order to submit things properly. And actually, you'll need it to create your project 4. So please be sure to do that. Super, super important. And of course, please feel free to reach out on whatever channel, maybe the Getting Started channel, if you encounter any problems. And once again, I apologize for having those bugs in the code. It should be better now. Let me know if you have any problems. Did anybody, while I was going through that, did anybody try it? And did anybody encounter any problems? Okay, Jacob, work for you. Thank you. Good, good, good. Okay. Woohoo! Magic, right? Okay. And trust me, this is so much better than it was 20 years ago. Oh my gosh, Git is it's we will look back on it and we'll see how much it really helped our entire industry, our entire field. Okay. Last, and I know it's late, but we had a lot of stuff to cover, a lot of ground to cover tonight. Project 2. Okay. In Project 1, we created the fundamental classes. You have your airline, you have your flight, you have a command line program that doesn't do much of anything. Project 2, things start to get a little bit more interesting. In Project 2, you're going to learn about the Java I/O APIs by storing an airline in a text file. This project is due in 2 weeks on January 26th. Is that right? Is today already the 12th? It is. On January 26th. And the whole thing is worth 7 points, 6 points for the code, 1 point for the POA. In addition to the classes that you created for Project 1 in your package, there are 3 more classes that you need. The first is called Text Dumper, which implements the airline dumper interface, and this basically creates a text representation of an airline, including its flights. By the way, the format of this text file is completely up to you. The only requirement is that it be text and not binary. So I need the grader to be able to look at it and say, yep, there's an airline in there. And then also it has to be able to be read by your text parser, which is a class that you write that implements airline parser. So it takes that same text output, a text file, and then reads it and creates an airline from it. This code is driven from a Project 2 class, which contains a main method that basically does the similar stuff, does everything project 1 does, plus something new. So the new thing here is a -text file option. And -text file specifies where the airline file should be read from and written to. Everything else, though, is the same, including the format of the dates and times. Because a couple of things to note here. You do not need to create a new Maven project. Please don't. The intent is that you evolve your project 1 code base to meet the new requirements. There's also a parameterized type T in the abstract airline. In the text dumper. So then this is an opportunity for you to learn about generic types. If you have questions, please ask them. There's some important things to note about project 2. When you run the main program, if the text file does not already exist, this is not an error, right? You got to start somewhere. So if it doesn't exist, that's cool. Just keep on going. Create the empty airline, add the flight to it, and write its contents out to the text file. Note that the text file, the file provided to the program can be any valid file path. It can be an absolute file path from the root of the file system. It can be relative to the current working directory. Please don't make any assumptions about the file. It can be anywhere. And same thing about the name of the file, right? It doesn't have to end in txt. Any valid file name for on Linux, when I run it, it should be allowed. So please don't, it's got a number in it. That's not, nope. There are no requirements for the file name. Error handling. Again, be graceful. And now you're doing one more thing. You're reading and writing from a file. If the file is messed up, it should have a graceful error message. There's a new requirement. If the airline name given on the command line doesn't match the one in the text file, it's an error. So a couple of years ago, I started leveraging Java resources for like the README, right? We saw that a little while ago. The README can be read from a resource. Your text files for project 2 should not be read as resources. This is something that last term students really struggled with. It was something that I clearly didn't explain well enough, so I'll attempt to do that now. From the command line, when you say -text file, do not load that as a resource. Load that from the file system using the Java IO file API. Those are meant to be files. Now, if you look at the code that was created in the Maven archetype, I did provide some examples of how to use the text parser and the text dumper. Text parser, for instance, actually, I'm just going to close all these over here. Close the groups in this tab. The text parser test does use resources. And so I've started an implementation of a text parser for you that reads a text representation of an airline from in this case it reads it from what's called a reader, which you'll learn about if you haven't already in the Java IO lecture. In this test, we load it as a stream. And this is really nice. What this test does is it allows you to have sort of canned text files that you can read in. So for instance, here you have this one says, hey, listen, if you have an empty airline, so empty airline, I believe is an empty file, doesn't have anything. If you try to parse that with your text parser, it's going to throw a parser exception. Right, so this way you can have static files that are here as resources, load them into your tests, and then you can try to parse them and make sure the right thing happens. So, for instance, here in this beginnings of a text parser, I basically say, hey, listen, the first line of the text that is passed in is going to be the airline name. And so here I have a test that says, great, I'm going to take this valid airline text file, which just contains one line, the test airline. I'm going to create a text parser for that resource. I am going to call the parse method on that, and what it returns is an airline whose name is test airline. And this is meant to be the beginnings of, this is how you do test-driven development with your with your text files. Is that you can say, hey, I expect an airline, when I parse an airline with when I parse a file, when I parse text with a certain format, I expect to be able to get this airline. But when it comes to your main method, do not use the resources API, use the Java IO file API. Resources only live with your source code or get bundled into your jar. When I test your code, I am going to specify some file in the file system. It won't be in your jar file. This is something that, here again, people got tripped up on last time. I hope I'm doing a better job explaining it. But if you have questions, let me know. This is slightly advanced stuff, but it makes for good testing. And I think it's a lesson that's worth learning. You might also see there's XML stuff in here. That is project 4, is XML. Right. So just to reiterate, resources for testing, resources for your README, everything else is a Java IO file. And that is project 2. That is due in 2 weeks. Any questions on that? Phew, that's everything on the list. That's everything for tonight. So, oh my gosh, did we cover a lot, right? After doing some Prime Minister's questions, we did some test-driven development, and we saw how we could apply TDD to implementing the logic around the gender pronoun for the student. Then we focused on the command line for the student program, very similar to the command line for your projects 1 and 2. We brainstormed together. Actually, you all brainstormed. You did the hard work. I just read things off of a Google Doc that specified all of these test scenarios for the student program. As a matter of fact, we did this once. So let's call it green. I'm a big fan of checking things off. I just like my checklist. Clearly, right? I like my checklist. Gives me a sense of accomplishment. Then we implemented a number of these tests using integration tests, right? Integration tests are different from unit tests in that they focus on the main method. They allow you to do things like capture what's written to standard output and standard error, and also when you call system.exit. We also looked at continuous integration using GitHub Actions, and you saw that every time I made a code push to my GitHub repository, there were a whole bunch of tests that were automatically run, and lo and behold, it found an error that I had inadvertently introduced. And of course, this testing is really important to you all because it's part of your projects, right? So as part of your projects, you are required to have 75% code coverage, and every class be exercised by at least one test. We also learned how to provide documentation for your projects, and that comes in 3 forms. There's a plan of attack, which is due 3 days before the project is due. There is the Java doc that is required for you to write, and then there's the -readme option for your projects. Then we saw how to submit the projects using the submit.sh script, and we did a little journey through GitHub magic that allows you to get some changes that I made to my code base over the weekend, get those into your projects so that you can submit the projects and you can create the project 5 code base. And finally, we talked about project 2 and how you're going to, in project 2, you're going to build upon your project 1 to store an airline in a text file. So, oh my goodness, that was a lot. And okay, I took the entire 4 hours. Thank you for sticking with it. I will post the recording to YouTube as soon as I can. Watch both the course website and also the class recordings channel in Slack for information about that. Any questions about what you saw tonight? You saw a lot. Okay. Wait. Yep. Have several over Slack later. That's fine. So, thank you once again for attending tonight in person. Thank you for watching at home. Please feel to reach out at any time. I'm happy to reply to your Slacks and your emails if you want to sit down in person. Let's schedule some time. We'll figure it out. We'll be back again next week. In the meantime, there is the POA that is due on POA for Project 1 is due Sunday at 5 p.m. POA for Project 1 is due Sunday at 5 p.m. Project 1 is due a week from tonight at 5 p.m. And please be sure to get started on the cones. Those tend to creep up on you. There's a lot of stuff to do there. If you do a little bit of it, it's very manageable. If you save it all at the last minute, it'll be pretty awful. So, okay. Have a great evening, everybody. Stay safe, stay warm. Please take care. I look forward to seeing you all again in another week. Bye now.